Good morning, everyone. Hello and good morning, everybody. This is Manish Singh, trainer for our training. So I hope I'm clearly audible and my screen is visible, right? Can you do a small confirmation in the chat window? Can you give a small confirmation in chat window, everybody? And a small request, Dhanu, please mute. If possible, yeah, I have muted. Yes. Yes. All right. Hello. Yeah, it was noise by some of my participants was unmuted themselves. So that was the things was there. Now I hope it is clearly audible. Now I hope it is clearly audible to everybody. Can you confirm once?
Yes, Manish.
Great. All right. So here already our colleague has messaged for any lab support. There is a phone number available. I'm rechatting the same. I hope everybody have got it. I'll rechat that same message. This is the mobile number. You can keep it with you throughout the training. In case if you have any problem, we have our colleague, Mr. Gopinath. He will help you out with the lab support. Generally, nothing will happen. Our team is so confident in that. But in case something goes wrong, he'll help you out. All right. So before starting the agenda for the day, I'll start with a quick introduction of myself. And then there are so many questions he's asking. Ankur, is anyone speaking? I'm seeing Manish, you are typing something on the screen. And I'm speaking to Ankur. Hello, Ankur. Yeah. Yeah, I have message to Ankur. Yeah. So slowly we will just try to start our agenda for the day. I'll start with a quick introductions of mine. I am Manish Singh. I have total 12 years of corporate experience. And for last 8 years, I'm in a big data field. In this big data related to all stuff related to big data. starting with your Hadoop, Spark, Cassandra, MongoDB, streaming technology, Kafka Streams, NoSQL database, Cassandra, HBase, and all. So these are my major area of specializations. Apart from that, data science, machine learning, and in cloud technology, Azure as well as the AWS cloud. So my major area of specialization is this all. And we are going to have a complete 5 days of session on Spark and starting with the big data, then we'll start with the Spark, and final day we'll be talking about the Kafka also. So that is my small introductions about myself. Now, next agenda, I'll ask your introductions in the chat window. I repeat, in the chat window, I need your small introduction. In that introduction, I need three things. Number one, what is your year of experience? What are the tools and technology have you worked on? And what are the programming skills do you have? Only these three things I need. Kindly write everything in the single chat, space separated, and then hit enter. I repeat, don't write year of experience and hit enter. If you hit enter, message will reach to me, and that will be simply multiple message you have to type. So better you do space separated values, or maybe any other delimiter you can use it, maybe comma or backslash or like this, and then you do a single enter. That's all. Do a single enter. That's all. Again, guys, hello Shravan. What I told, you have not listened. Hello Shravan. Good morning. What I am saying, just type everything in continuation. Type everything in continuation. If possible, delimiter, you can use comma or backslash or front slash or hash or whatever. Do that and send a single chat that will give me a clear picture about my audience. Over to you. Yes. Just now, Faizdin have sent me like this. He's having total 14 years of experience working with Informatica, SQL, Unix shell scripting. Very good. Like this way. Single chat, and that's all. Over to you guys. I'm watching your chats. All right. So approximately they have given a small introduction about themselves. I'm able to see all of my folks are very senior folks with us. Not no lateral or no entry level or nothing. Very senior folks we have, and on an average they have a 10 plus years of experience. However, they are coming from all ETL background. Majority of them they are from Informatica. They have a SQL and all knowledge. Some of them they have a Python, Abinito, and shell scripting. Many of them they have already worked with a C sharp and all. Great. And some of my friend like Ankur is working on a big data tools. Ankur, can you little bit explain about your big data expertise? Hello, Ankur.
Hello. Yeah, Manish, can you hear me?
Yes, please, please.
Hi. So yeah, as I think we discussed, right? So we are working on big data application support team. So multiple big data applications as part of our CCB consumer banking is getting migrated to big data application, and we are kind of supporting those applications and working with them.
Mm-hmm. Yeah. So I hope you received the mail from us, right? Like we were
Correct.
requesting for that this sort setup and all. So you know that, right? So something we can do and something we can't. So we have clearly mailed to the team.
Yeah, I
So,
think we are good. Yep.
yes,
Good.
yes. So that should not create any these things. Yeah. All right, great. Anyway, apart from that, everything will be great. Way. Good. Thank you. Then we have a Sara with us, Dhanu, same Informatica, cell scripting. All right. Then Benito. Okay, great. All right. Approximately the same background. Now, third agenda for the day in introductions part. Mine introductions already you guys have heard. Your introductions everybody have heard from each other. The third one, our TOC. What we are going to have during these 5 days. Let's have a quick round of have a look of this all what we are going to have. So this is the curriculum what we are going to discuss, and little bit I'll keep in mind that you are going to do the production support. So I'll try as much as possible things to keep in mind and try to give you the perspective in that way. All right, guys, this is the curriculum. What already you have this curriculum. It's not about I am going to show it first time to you. You already have this, but I'll just walk through it once again. Today, we are going to start with firstly, I'll give a brief overview. What is big data? You guys are coming from Informatica background, and why big data is concerned. How Hadoop is different than other ETL tool what you already have worked. Why somebody is looking for some specialized things, why we need it. So we'll start with that introduction part. And then we will see, oh, what existing ETL tool is working, that is not sufficient. Then I need something better. So we got a Hadoop in market. And in a Hadoop also, what are the components are there, how they work, and then what is the drawback of it. Once we will see the drawback of a Hadoop, then of course you need the better solutions. If you need the better solution, I will introduce you with the Spark. Maybe it will take 1 hour to finish up to this understanding part, and then we'll come to here. Approximately before lunch, we can finish up to architecture. Because in quite deep, we are going to understand. It's not about outer view. My training will be a little deeper one, understanding you are going to do, so that after this, you will not face anything, any issues in your concepts wise. And then we will be seeing how Spark is faster than the other MapReduce programming and what is the reason behind it. So we'll be discussing, oh, this is the RDD, which makes it totally fast than the other frameworks. So we will see what is the RDD. We are going to create our own RDD, and there are two ways I can create the RDD. One from the internal collections, as you know, lists, arrays, sequence, structs. So I will teach you how to create an RDD from internal collections. And then even I will teach how to create a RDD from an external files, what client will give it to you. And here only I'll be teaching variety of files, but not today everything. Today we will just work with a text file and with a CSV file. In the day 3, I'll be teaching with the other file formats like a JSON file, XML file, and other Parquet files, Avro files, and all. So day 3 we'll be discussing about other file formats. Today and tomorrow also we'll be working with only single text file and the CSV files. So how to create a RDD, and then once RDD has been created, what are the operations can I do on my RDD? So we are going to learn variety of transformations and the actions. In this transformation, approximately 16 transformations I am going to teach, plus user defined functions, what you can write it. And later we'll be talking about the actions. Again, variety of actions we'll be doing, and I'll be comparing which action, how that touch to the hardware, how it gets executed, which operation is better and which one is more costly in terms of resource consumptions. That all time to time we'll be talking about. And in transformation, there are variety of transformations we will learn. One such is called filter. Then we have a map, flat map, union. So 3, 4 we can finish today, and then tomorrow we'll be continuing with the same topic. Intersection, union. Now these are the actions. These are the actions. Later we'll be talking about what is pair RDD. This one will be talking only about the singleton RDD. Then I will discuss about the pair RDD. What is the pair RDD and how it is different than that, and what are the options available with the pair RDD. Then once pair RDD we have done, we are going to talk on pair RDD some operations like group by key, sort by key, join, map partition, fold by key. We'll be talking about sort by key, aggregate, combine, and all. So we'll be talking. So by end of tomorrow, we can finish up to this all. Lately, tomorrow evening, I'll be talking about DAG, and we'll be talking about cache and persistence, this topic. And then we'll be talking about accumulators, broadcast variables. These are the some advanced concepts available we'll be discussing, and practically we are going to do that. Then day 3 we'll be talking how can I create a jar file and I can run it on cluster. As a discussion point, today itself onwards we'll be talking with the cluster labels. Now, how can I submit a job in a cluster and how the resources will be utilized? And then there are some advanced concepts available. In that, we are going to discuss about what is the partitioning. So not today, tomorrow onwards we'll be start talking about this. Day 3 we'll be talking about this one, narrow dependency and wide dependency. And soon after this, I'll be talking about this topic, what I discussed, caching and persistence. This topic. Because firstly, I'll discuss narrow and wide, and then I will discuss this because they are connected together. We'll be talking about what is shuffling and how DAGs are getting created. So DAG will be discussed today also and tomorrow also, day 3 also. Till day 3, every day DAG will be discussed. In the DAG, we'll be discussing what is the stages, how the jobs are splitted, what is tasks, and if it is going to be a normal Hadoop, how many tasks will be there, and if it is a Spark, how many tasks will be there. how these stages are getting divided, what is the factor behind it, what is the tasks, what is the job, that everything crystal clear view you are going to have. Then we'll be discussing about how to join two data sets, or we can say two RDDs. And what if you have got some null values? What if we got some null values? So these are some additional point during the call discussion we got. So I will try to incorporate that all. How much is possible, I'll try to do. Again, day 3, we'll be discussing about Spark submit job. And at that time only, I'll be discussing how can I submit a job. I can simply submit a job and leave all the resource allocation with the default. Or I can give my own parameters, like how many number of executors I want to give and what is the amount of memory I want to give for each executors. How Spark is fault tolerant, that everything. And we will be looking for Spark Web UI logs. I repeat, during this all phases, day 2 onwards, we'll be looking for Spark UI logs. Yarn will not be able to see because we don't have a cluster. In a local mode, we are going to work. So Yarn is not possible. However, Spark Web UI, I'll be discussing. And all the logs will be discussing about this. And we will be seeing how the executors and the drivers are going to be work. And accumulators and broadcast variable will be discussed during the same time. Once this all is done, we'll be going for your favorite topic. I repeat, once this much things has been done, approximately at end of the day 3, we will finish up to here. On a day 4, we'll go for your favorite topic. And you'll be saying, my favorite topic? Yes. You all, my dear friends, are coming from ETL backgrounds or Informatica or something like that. Basically, you are saying you are a SQL experts. You are a SQL experts. And you know that Spark speaks SQL. Spark speaks SQL. We call it a Spark SQL. So day 4, we'll be discussing with the Spark SQL. Now we'll be saying, oh my God, good. No stress. Day 4, it's your area. Day 4, it's your area. And you know, you can write any query in that because you have spent years together in the SQL domain. So day 4, we are going to discuss. And since it's your area, we have given very less weightage for this because my job will be just to tell you and show me some 5 or 6 problems. That's all. Apart from that, you buddies can take over from that point. So that's why it's little less weightage. However, I'll be discussing about how to create a SQL context, then sessions, how to create a data frame, what is a data sets, how to create a table, how to save it, how to write a queries. And in queries, 5 to 7 queries or maybe 10, I will show it. That is not a problem. But you know, SQL means if 10 queries I will show in the class, you can write thousands and thousands by your own. So I will leave from here, day 4 with the Spark SQL concepts. And day 4 itself, as I told, I'll be discussing about other file formats. Text today itself will be covered. CSV today it will be covered. Day 4, I'll be talking with the JSON, XML, binary file formats like a ORC file or Parquet file. And UDF, user defined functions, how to write a functions, day 4 will be discussing. And I will teach you how to convert a RDD to the data sets, to the data frame, or from a data frame to the RDD, and interoperability, like how I can convert one from the other. And again, here also, we will go and play with the join operations using the SQL. Again, how can I write UDF, user defined functions? you might be knowing UDF means what. Let us suppose Spark functionality. I'm not happy with this all. So you can write your own functions. Spark has a capability to integrate that. So I will teach you how can you write your own functionalities, and we are going to. Then caching already has been done by day 3 itself. It will be finished. So no need to do one more time. Day 5, we are going to start with the Kafka. Morning hours, we are going to take approximately 2 to 3 hours of complete understanding of Kafka. What is Kafka and what is the streaming? So firstly, we will work with the Kafka. We will create a topic. We will create a producer, everything. And then second half, we will discuss what is Spark streaming, how it can work with Spark. And I will connect the Kafka with the Spark. And I will show you real tweets coming from Twitter to my laptop, not your laptop. Because in that, I'll be using my credentials, and it's not a normal credentials, it's a Twitter developer account we need. Generally, it takes some time to get approval and all. So the credentials, maybe I will show in my system, and the same credential, if you want, I will share it to you also for temporary time, and then I will change the credentials. So in real time, I will fetch the tweets from the Twitter to your laptop. I will fetch, and you'll be saying, oh my God, there are thousands of tweets are coming every seconds. Yes, I will close my 5th day of session with the demo of the Twitter where Kafka and Spark both will be working together. So there are 3-4 examples in the Spark streaming also I'll be discussing. We'll start with a word count, and lastly, I will show you how can I get the tweets from the Twitter in your Kafka. So that will be the 5th day agenda last. So this is a simple walkthrough about what we are going to have complete 5 days. Here, I'll take a pause for some time, and you buddies, please have a look. And I will, if you don't have this, I will share it to you, the same one. One sec, give me a second. There is a link I'm going to share. If you are connected with a VPN company network, this link will not open. Okay. So if you disconnect with the VPN, it will open. This is the link I have shared in the chat window. And in the link, on the link, if you open, I have shared you the entire curriculum, what I have discussed. And I'll take a pause for some time so that you can aram se have a look. Have a look. Link I have shared to you in the chat window. If you open the link, entire course curriculum available here. You can have a look and please confirm. I'll take a pause here. All right. Everybody, please take some time, have a look of the curriculum. If you have any suggestions, I'm totally open to that. Not a problem. Slightly here and there, if you have some suggestions or something like that, please feel free to discuss. Feel free to discuss. Yes, my dear friends. Anybody have any suggestions, any alterations, or anything in the last moment? Any other additional things if you need, please. And if not, please give me a small confirmation in chat window. All good so that I can start further. Yes, my dear friends, I have handled multiple batches with JPMC, and you are the one next batch. And believe me, all old batches was very energetic throughout the day. Believe me, more than 500 chats we used to do. Okay, so that level of energy I want from this batch as well. Not now, even at 6 p.m. evening, always interactive I want. It's not silent mode. My classes are, and once again some disclaimer I am putting, guys, you keep your expectations from me that I must get a 5-star rating. Basically, you put your expectation at this. I am saying boldly to this because again I'm not asking you rate me 5. I will prove myself. I have to prove it, and then you judge me. That is what you are going to do. I have to prove it. It's my challenge. But you don't get compromise less than this. Are you getting my point? You don't get any compromise less than this. Acha, 5-star doesn't mean that, okay, everything based upon the curriculum only, okay, not like, okay, oh God, or not like that. Just as a trainer, and you do judge me on based upon this, what is available. Not like that, Manish, you have not taught this topic, not like that. Please, because sometimes different people have a different opinions. So based upon the curriculum, based upon the interactions, your knowledge, your expertise, what you are getting, how good I'm communicating to you, based upon that all, I have to prove. Yes, my dear friends.
Yeah, Manish, I can say all the best to you and all the best to all people.
Yes, thank you so much. Yes, Basha, everything will be done. Don't worry. Don't worry. Everything will be done. After my first day of a session, you by evening you'll say, I know everything. SBT, I will teach Chiranjeevi, not a problem. Instead of SBT, Maven, is it fine? Maven? Chiranjeevi, Maven I'll teach, or SBT also, your choice. Both I will cover. All right, guys. Chalo. So a big cheer up, everybody. Please say yes. Thumbs up at least. Everybody.
Yes.
Good. All all right. All right, my dear. Let's try to say here. I will start with the very basics with firstly, we talk about big data. I start my discussion before the big data, I start with the data. And who else knows better definition of a data than you guys? Because you have spent years together on a data. You have spent years together in the data, not 1, 2, multiple years. So you understand data better than me. That's sure. I'm very much sure about it. But I'll take just one silly example of a data. You know what? What is most precious in your life? Most precious things in your life? You know that? Of some of my friends will be thinking, yes, I know, I have a car, or I have a jewelry, or I have a wife, or I have a son, or I have a daughter, or whatever. It can be most precious in your life. Or somebody can say it's a life itself very good. But in life, I have written, don't you think to all this, whether it is maybe a wife or parents or kids or the car or the job or the jewelry or the memories or whatever, a data is most precious in your life? Because that all memories what you are talking you have stored in your brain in a form of a data. By today 9 a.m. you don't know who is going to be my trainer. But now you know it's Manish Singh. So what did you do? You have heard my name and you have inserted in your memory, in your brain, that he is going to be my trainer for our Spark. So it's basically one data you have inserted in your brain, and you will remember me for some years or maybe for some month. And then slowly you will forget me. Slowly you'll forget me. It happens. It's just a data. And same thing happening with any part of your life. Multiple friends have studied with you in your childhood and you have forgotten their face or something like that. Even teachers' faces we have forgot. Slowly it will get erased. It's a hardcore fact. But at that time, it was available in your brain in a form of a data, nothing else than that. And believe me, we are so lucky that we have such data available in my memory that I can tell it's me. I can say that it's me, or it's my wife, my kid, my laptop, my car, my job. I can say this only because data is available in my brain. But not everybody is so lucky, okay? Not everybody is so lucky. Multiple times, if you go to Nimhans, right? Here, Bangalore One Hospital, mental hospital I'm talking about, or maybe in movies, people you might have heard, or Gajni. Gajni, who am I? Who am I? You might have heard in the very movies, who am I? Who are you? Many people, they ask it, and that too, doctors say he has lost his memory. The moment you lost your memory, you will come to this stage called Gajni state, we can say. In funny way, we can say it's a Gajni state. Where you can't recognize yourself itself. Then where is the memory? Where is the wife? Where is the parents? You can't recognize yourself itself. Forget about the parents or mom or dad or kids or jobs or whatever, or any memory you have gone to holiday or nothing. Nothing. So data is most precious in my life, guys. I hope you got a better definition of a data than what you till now you were thought. You have spent years together for a data. I hope this definition added advantage to that. So what I am saying, data is most precious in your life. Now don't say this to your life partner. They will feel bad because till yesterday you are saying I am the most precious, and today you are saying data is most precious. Who is this data? Who is this data? So your partners will feel bad. Oh, why you are changing your wordings? Yes, it's a lie. So now it's the most precious part is the data. So maybe wife or maybe husband, they will start doubting, who is this data? You can say Julie data or something like that. Any English name you can add and then the data. So it's the most precious part is the data. And do you know that due to this region, we want to store the data in memory, because how much more data you can store in memory, that much better you can perform in your life. How much more data you can store in your memory, that much better you can perform in your life. And due to this region, everybody start storing the data in the memory. And even we say to our kids, just remember this formula, a plus b ka whole square, this. So many things you kept in your brain. Because we are hungry of it. We want our system to perform better and better and better. And for that, driving force is the data. And it's a fact of your individual life. Believe me, a corporate life, or we can say business, is no wonder. And for them also, data is most precious things. Data is most precious things that is available in their business. Any business you take up. Let us suppose I'm talking about banking and I'm taking example of State Bank of India, and they have a data for user accounts, and in my account maybe they will say Manish have total saving of 50,000 rupees in his account, and like that multiple customer details they have, and tomorrow I come to know that their database got crashed, I know that. Then I'll go to the bank and I'll say, sir, I have kept 50 lakhs rupees in my bank. Please give me the compensation. And they have to, because in that condition, they don't have a data. They don't have a data. So what customer is doing, they have to do the bargaining and they have to settle their account with that because it's their fault. Don't you think in this condition they will lose their business? Bank will get bankrupted in this case. Similarly, you take another example called Amazon.in. You are ordering thousands of items every day. Many people are ordering multiple items. And Amazon has just lost their data. Who has ordered what? Now, don't you think company will lose their faith in one single day? Because there will be thousands of complaints that I have ordered fridge and you have taken my money and you have not delivered it. You have not delivered it. So company will just to save their brand, they will deliver it. And there are multiple customers, they have not ordered, but they will start claiming, even I have ordered because I know your data has been lost. In that condition, you will lose your business. You will lose your business. So not only for the business life, personal life, even for professional business, data is the most driving force available in your life. It's all about the data which is driving the entire globe. It can be a banking, or you have a mobile number, or you have any call, or whatever you think. Everything is running on a data. Everything is running on a data. And that you buddies know in a better way. You buddies know in a better way. And this all data, people wants to store it. Since everything is driven by the data, I want to store it. I want to store it. As like a normal life, I told you how much more data I'll store in my memory, in my brain, I can perform better. Same way, how much more data company will store, company can perform better, company can store better. And for that reason, company wants to store this all data in their database. Or you guys will say data warehouse, whatever. So we are going to store this all data in the database. Very good. Now, before database also, if you take one example, and if you have a small data, then you will say, I will store in Excel sheet and I'm happy. No problem. Even I'm happy. Excel sheet. Excellent. Or before Excel sheet, brain itself. I'll store in the brain. Okay. But if you have a more data, brain cannot hold this all. So you need a tool. And Excel is the best, one of the best tools that's possible. Now you came to the Excel sheet and you have stored all the data available here. Now, again, I am saying data size increases. Data size increases. Now, what will you do that? Maybe Excel sheet you are talking, so you can say 1 GB, it will not open. You know that Excel will not open with a 1 GB or 2 GB file. It's not possible. It will throw, I cannot load everything using Excel, sorry. So if the data size increases and goes beyond the GBs, Excel will start hanging and it will say, I cannot open this. I cannot open this. Then what will you do that? Then you say, okay, then I will prepare one more Excel sheet. ठीक है. You open the Excel sheet, no problem. But I want to do a query. So now same query, I have to run against this file once, and again same file against this once, because I want to do a filter operations. Filter all the sales is having greater than 5,000 rupees. So I have to filter in here, and then again I have to filter from this Excel sheet, because Excel sheet will not give you a query capability with multiple Excel sheets at a time. You cannot filter from 2 Excel sheets at a time. So you have to run 2 times. This is the big problem. There are 2 things problem we have seen. Number 1, if size increases, you can't hold it. And number 2, I cannot do a query on a 2 Excel sheet at a time. And due to this 2 problem, people was looking for such things that can hold it, that can solve. And as a result, RDBMS has came in market. Relational database management system has came in market. You know, back in 70s, 80s, I'm talking. And RDBMS is saying, no problem. If you have a 1 GB data, 2 GB data, 5 GB data, I can help you, no problem. And you want to query one table with the other table, I can help you, please don't worry. I can help you, don't worry. So RDBMS was very cool, actually. I'll say one rough and tough word. RDBMS was very cool. And believe me, it is the one of the best tool available till today, I can say. On a lighter note, it's one of the best tool that can be possible. Everything was cool. There is no problem at all. Now, point to be noted, I am just going back in story, and I'll say till 2000, year 2000, everybody was saying, cool, RDBMS hai now, everything RDBMS will handle. My database, entire world was enjoying the speed of the RDBMS. Believe me, till today, none of the software can give you the speed what RDBMS is giving. None of the other softwares. It's one of the super cool softwares available. Till year 2000, everybody was saying RDBMS is the coolest guy possible. Suddenly to this world, something has happened. Parallel to this, this is the one story going on, and where world was enjoying the RDBMS. Parallel to this, there is something extra has happened, and that extra thing's name is called internet. Now this story, let it be here only. You know, internet has came from 1995 onwards. And you know, the nature of the internet, everybody knows it. Somebody keeps the data on their server at some places, and anybody and everybody can access that data from across the globe. Okay, cool. If I ask about your use cases, no bookies, your life. If I'll ask you, in year 2000, how much data do you consume in a month during those days? All of my folks are almost approximately of my age only, or maybe 2-3 years elder or younger. So at that time, I don't think anybody was using internet data more than this, because it's a fact story. It's not a bookish story. It's a fact. Guys, do you agree? 10 MB per month? Because during those days, no dynamic pages. Everything was simple text. Everything was text. Yes or no? Do you agree with me? This one small data I have written. What is it true with you as well? Great. Yes. So if I'll talk about year 2005, then you say, sir, during this time I was going on internet, but it was not there at my home. I used to go to internet cafe, and I used to pay 20 rupees, 30 rupees or 40 rupees based upon the city you live in. And for 1 hour, I used to browse and then come home. Like this was the story during those days. And if I look for on a higher side, I look this much data you used to consume per month. If I go a better years, if further down the line, if we'll go 2010, you say, oh, this time I got internet at my home. And that too, not everybody. Very costly during those days. I remembered it. It was very costly. During those days, even mobile internet, in my mobile, it was not there because it was costing very huge money for only for internet. I will go with this. This much data plan people was there during 2010. Now, if I'll go for 2015, in India, there was a digital revolution has happened, and that has been done by our loved company, Reliance Jio. Reliance Jio had changed the entire way people are using the internet. It was, I say from my wordings, it was a revolution. It was a revolution. And we came in this group per day. Many of them, many of us are there who is even better than this plan, 2 GB or 3 GB. But go on a lower side. Let's go on a lower side. So if I'll go here on the lower side, if I'll say it will be approximately 25 GB per month. Again, I'm taking lower side. And here I have taken upper side. Have a look. Now, don't you think, oh my God, it's me. Yes, it's you. It's you. How much more data are you consuming? Do you know that? It's 25,000 times more data you are consuming. Forget about the book's world. You alone are consuming more than 25,000 times more data than year 2000. And like you, think the population of our country. And as an overall globe, you think the data, what is being generated. So data size, just think. Just think the size of the data, what people are consuming. Just think. I can't do the calculation, my God. I can't do the calculations. This calculator won't support it. This calculator won't support it. You just think. So it's a large, or we can say extra or double large. Data size is large. Simple large word I am saying. Now, whatever this data you are consuming, so this all data basically are divided into, basically it was generated by the two bodies. Generated by two bodies. Or we'll be saying, sir, me and my wife. No, sir. Not by you and your wife. Data generated by two bodies. Bodies means not you and your wife or maybe husband. It's just by a humans. And we guys are living in a smart world where smart devices we have. Where we have smart devices. Now smart devices means doesn't mean that only your phones. I am talking about satellites. Satellites. I'm talking about the sensors. I'm talking about web cameras. Web cameras. And etc. You know, there are 24/7 cameras are there which is working. There are so many CCTV cameras are working 24/7. And there are so many satellites, network sensors, firewalls in your office. There are so many things are there, and that is generating a data 24/7. And if this example is very tough, your mobile phone is the sufficient. Your mobile phone is sufficient, which is generating huge amount of a data every seconds. And you know that there are multiple apps are there. They are capturing your data and they're sending to somebody. maybe some other country also. You know the facts of the things. Because in the globe, there is nothing, even though you are not touching it, but somebody is storing some data from the other app to other app. They are just doing it. And this is happening because while installing the app, you have given the permission, I want to assess your contacts. Okay. Why okay? I want to assess your gallery. Why gallery, sir? Make my trip. Why gallery? I want to assess your photograph. Why? But we say yes, yes, yes. Gone. So there are so many apps are there. They have a full permission to do anything and everything in your phone. Even audio, my dear friends, audio. Okay. Means they can do the audio recordings or something they can do. Videos, okay. Okay. You know that. Smart devices. And humans, though, why to discuss? We guys are well sufficient to generate a data because whole day you are only doing this. Whatever this 25 GB I have taken, it's you. No devices, no satellites. No satellites, it's you who is generating a data. Now, don't you think, sir, this data is not large, sir. It's extra large. This data is extra large. Point to be noted. Now data is extra large. Okay, happy, agreed. Now this all data, what was being generated over the internet? So what do you do basically? What humans are doing basically? With this data, what do you do? So you'll be saying, sir, I am spending my life on a Facebook, LinkedIn, and etc. Twitter or etc. like this. Then somebody will say, I'm on a Netflix, I'm on Amazon Prime, I'm on YouTube, etc. Somebody will say, I am doing e-commerce. Always flipkart.com, this.com, that is seeing the t-shirt, seeing the jeans, seeing something they seeing. E-commerce. Sometimes I do lots of spelling mistake. Please pardon me. Because while typing, I just type it something. I am just teaching in a mood actually. So please pardon me for some time I'll do a spelling mistake. So there are so many e-commerce websites are there. You go and look for so many items. Similarly, somebody will say nowadays, it's for last 1 year, I am saying, gaming. There are multiple people are there who are doing gaming on the mobile. And apart from that, there is silly things here and there that possible. So basically this all 25 GB, whatever you are spending for this work. And now, don't you think there is a huge business involved everywhere? There is a huge business involved everywhere. Yes or no? Everywhere. There is a huge business. Maybe a Netflix, maybe Amazon Prime, maybe everywhere there is a huge business is available. Of now, many of them, they'll think, yes, I know the business is available. E-commerce. Yes, let's take example of Amazon. Name I am taking, please. Amazon.in. You just open the website and you just click on some product. That's all. You forget it. You click and don't buy it. If you are buying, it's fine. That is not a problem. But you don't buy. And then see the magic. You open Amazon.in, search for a mobile phone or maybe a book, and then don't buy, close it, and then see the magic. Magic in terms of in your email ID promotion, you say the what kind of a promotion messages you are getting. Next, you go to your Facebook page and see the what kind of ad you are seeing. Go on a Google and see what kind of ad you are seeing. Everywhere, wherever you go, you will get the similar ad. Oh, printer ad is coming. Printer ad is coming. Everywhere the same ad. See the magic. It's just like a salesman is running behind you. Where you go, the salesman will show the same picture. Sir, please buy, sir. Please buy, sir. Please buy, sir. And on some page or someday, coupons will come to you, offers will come to you, and you'll buy it. You'll buy it. See the effect. Day one, you have seen and you have closed it. I don't want. But after seeing the ads, after seeing so many things, pages and all, you are going and buying it. And this is the analytics being done today. This is the business I'm talking. It's not about that I have gone to Amazon and bought the product. No, if you have bought, means good. If you have not bought, then it's a business starts. So I'm talking about the click streams. Wherever you click, company records it. How many pages have you visited? Company records it. And company try to give you the promotions and offers on such products what you have clicked on. What product you have not clicked, believe me, you will never get any promotions for that. Until it is a new releases. So this is where click streams people are recording. And apart from that, your mouse movements also are getting recorded. Mouse movements, guys. Yes. So this all is happening. Let's take one more example of it so that you will be having better clarity. Let's say I'll take one example of my one friend name I'll take. Let's take example of Shravan. Shravan is there with us. Let's take Shravan is having a credit card and he is going to book a ticket from Make My Trip or any company. From here to London, he has booked a ticket. I know in lockdown not possible, but it's fine. He is going to London and he has booked a ticket with his credit card on some websites. It's fine. You have booked it. This information, bank knows that you have booked a ticket. And this much money you have spent to buying a ticket from Bangalore to London for this date, and you are traveling by this, everything bank knows it because you have did a transactions with that. Now, just assume bank is a very gentleman and he will not tell to anybody. It's a gentleman. He will not tell to anybody. It's a kept secret. Okay, I believe it. But what about Shravan? Will you not go to your Facebook page, your LinkedIn profile, your Twitter, and you share this information with your friends and families that, hey, I'm going to London? Maybe Shravan will not share, but other friends, though, nowadays, right? Even people are having chicken. People are clicking and keeping it. Oh, I'm having chicken today. Guys, are you getting my point? You will go and share this information to Facebook. You will go and tell anybody on a Twitter about this. Your friends and family will feel happy. Some of them, they will feel jealous as well. Some of them, they will feel jealous as well. Now, there are so many other birdies who are feel very happy. Now you may think who they are. Who they are? So they are the travel insurance guy, the guy who is selling travel insurances. You know that if you are going from Bangalore to London, you need a travel insurance. You need a hotel to stay. You need a hotel restaurant for food. You need some places to visit. You need a cabs as well. So these are the guys who needs all this information, and they will start capturing your tweets from your Twitter. Like how I will show on a day 5 that I will capture the tweets. So this guys captures the tweets and they finds who is talking, where they are going and all. And based upon that such information, all such informations, they try to grab you. They try to find the business for you. They will try to sell insurance products for you. they will sell it. And this all is happening, guys. This all is happening. So there are so many guys out there, though, who capture the data from the tweets, from your LinkedIn, there are so many industries are available in this, whose business is this only. And you will be thinking, I have not shared my number to this guy. How this guy is calling to me? How I got a promotion for the travel insurance? I too have, sir, they are all linked. There are somebody who has captured the data on your behalf from somewhere, and you, as a result, you are getting this all. So this all data is precious for the corporate life as well, because if you are buying a travel insurance, so earlier you was not a customer, basically. You have not gone to buy it. The company has approached you and they have sold it to you. So ultimately you was not a customer. You become the customer. Means whatever business company did it, that is extra business. That was not a normal business what they are doing. That is the extra. It's an extra business. Don't you think if a company is making just 10% extra business, huge money? Oh my God, billions of dollars ka 10%. So I'm talking, there is everywhere business is involved. It doesn't mean that direct, even indirect. And due to this all regions, all company, whatever company, they want to store the data, because until you store the data, you cannot analyze the data, you cannot contact to the customer, you cannot sell any product to them. And for that, you are going to store it. Now, point to be noted, guys, data size is large and I want to store the data. It means storage, more storage I need, because more data, more storage I need, and more storage you need means more cost is available. More cost, number one. So now storage cost is too high in case if you go with the normal here. Storage cost is too much high. That here, if you go with the normal, cost is too much high. Guys, I mean it, that I have written too, that I mean it actually. I don't know how, you know the cost of the databases or not, storage, but huge costly, because of the hardware what we are using in servers. It's too much costly. And you know that if I have searched on Amazon, it doesn't guarantee that I will buy it. So more storage you are spending, but that much profit I will get or not, that is not guaranteed. I will get, but the cost is matters. If you go with the normal conventional way of storing the data, its cost is too much. Cost is too much. Number one. And number two, whatever data are being generated over the internet, this all data is divided into three groups. Number one, it's going to be the structured data. Structured means what you deal with every day. Tabular data, normal RDBMS data. So you know that. Neat and clean and gentleman data. Gentleman data. Number two, we have called semi-structured data. We have semi-structured data. You know semi-structured means what? It's called JSON, XML, etc. And you know that your RDBMS tool, whatever you are working, that supports this both. Even Informatica supports the both. There is no problem. There is a third variety of a data also. What is being generated on internet, and that is called unstructured data. I repeat, unstructured data. Unstructured data means I'm talking about text data. What you are talking about, the chat messages, what you generate. Now, don't you think chat messages are unstructured? I don't follow any pattern. As you are saying in my white window, am I following any pattern while typing? No, I'm typing. I'm not following firstly ID, then name, then address. Not like that, sir. I am typing randomly something here, something there. It's unstructured data. So any chat messages, text. Hello, friends. There are some comments are coming.
I think Manish did the structured data with the images also, right?
I'm coming on that point. 1 second. My audio is clear, right? My audio is clear, guys. Yes. Sandri, please check yourself. Sandri, please yourself. There is no problem for the others. Kindly check. Some message has came like audio issue.
Yeah, Manish, now it's clear.
Now, what I was talking about, we have a unstructured data. And in unstructured data, we have something called text data, chat messages, or you can say about the log messages, what is being generated by your Informatica, your database servers. So don't you think this log messages, what is being generated, that is unstructured, that don't follow a same pattern in all? Guys, can you confirm this? Logs, is it structured data is getting generated or unstructured? Everybody, please.
It's unstructured.
Keep on typing, guys. I want everybody to keep on participates in the discussion. My teaching has to be like this way. You have to be something, type it. I'll keep you busy. So that no message or no phone calls. Okay. So yes, so sometime my logs will be generated like a semi-structured, or sometime it will be unstructured also. Likewise, I have the images that will be totally unstructured. I have the audio that is totally unstructured. I have the videos that is totally unstructured. And last couple of years, guys, I have the graphical data. Yes. You are using GPS, right? You are using Ola, Uber and all. Graphs are being generated. 5 years back, we were not using this more. It was very limited. And GPS and all, we were not using in 2010-11. So that data was not there. But today, graphs are there. And not, it's a huge, because anybody and everybody if travels to the new city or new places, graphs. So this is still very hot topic, graphs and all. It's still very hot topic, graphical analysis. And my dear friends, do you know one bad thing about it? Your RDBMS cannot support it. There is no tool. I'm talking about year 2002. So there is no tool can process it directly without conversions. We can process, at that time you have to do the conversions. What we call it is a ETL. Without ETL, you cannot process directly. There are no tools that can process this data directly. And now you'll be saying, what's the problem? I will convert it. Correct. You can convert it. But for conversion, there is a money involved. You don't convert it for free of cost. Manpower is involved, time is involved mostly, because to convert a data from unstructured to structured, you need 1 month time or 2 months time or sometimes 3 months time. And today we don't have a time because we are dealing with the e-commerce, we are dealing with the travel bookings. So the bookings has got failed. They will not book a ticket after a month. They will book after a day or maybe after an hour. If you are trying to buying a laptop and you have searched it and you have not bought today, doesn't mean that you will buy after 2 months. You'll buy within 3 or 4 days or 5 days. So you can say, I can convert in 3 days. Correct. But how much money is involved in that to conversion? You want quick conversion, more money company have to invest it. So people was looking, is there any tool that can directly process your unstructured data? Believe me, answer was no. And this one was the two problems. Number one, storage cost is too high. And number two, there is nobody who can process this tool directly. And Google did a conference. Google did a conference in year 2002. And he told this two problem, and he told it's a big data problem. It's a big data problem. Now you know the problem. Storage cost and no tool. Storage cost and number two, no tool can process unstructured data. So this two problem, Google raised it in year 2002. There was no tool that can process your unstructured data. And you know one hardcore fact, whatever data are being generated over internet, I repeat, whatever data are being generated over internet, 90% data are unstructured. 90%, my dear friends, you see the perspective, 90%. And it's no wonder, you have seen that my statistics, right? You are using 1 GB data for a day. So what you are doing, Facebook, Twitter and all, everything you are doing that only. How many time you are filling a complete form? Your name, Manish Kumar, city you live in, Bangalore. How many? In a day, nothing. I go on a Facebook, I go on Amazon, I go on this. Everything is a 90% data is going to be unstructured. And don't you think 90% data is unstructured and there is no tool for that can process it. Google raised this concern in a year 2002. And here in our class, we are discussing in 2020. In year 2020, we are discussing the same. Everybody has to feel the problem. I'll give a pause for 1 minute here. You can have a water, think the problem, and live with the problem at least 1 minute. Or maybe 2 minutes. Live with the problem.
Might be they kept as a confidential, I think, this one Google.
No, it was open conference during those times. It was open conference. They told it's going to be a problematic scenarios. Please live with the problem, have a water, 2 minutes. Everybody live with the problem. Yes, yes, Kiran, yes. Statistics are there. I have skipped that part actually. Actually, there are gigabytes of a data. It was in 2010, you know this, 4.4 gigabytes of a data was there. And this statistics is official IDC, International Data Centers. And they're told right now it's this much. You see the growth. In 10 years, 10 times. In 10 years, 10 times. Gigabytes, you know. Petabytes, so you know everybody. So 1024 petabytes is equal to 1 exabytes, and 1024 exabyte is equal to 1 petabytes. 1024 exabytes is equal to 1 gigabytes. So approximately every year, data is getting approximately one-fold. Every year, one-fold extra. Every year, one-fold extra. Oh my God. You see the growth of the data what we have. And for that only, there was no tool. And that was the big problem. So this was the two problems we were having. And I hope you have lived with the problem for some time. And you have feel it. Feeling has came, right? So people was during this, so we can't understand what is going on. During those times, so we are not internet guy only. Storage cost was too much high. Right now also, if you go to buy a server, what is available in JPMC, that crores more than some 20 or 30 crores. One server. Some servers will be there in your JPMC that crores hundreds of crores. Believe me, I'm saying fact. Some of you might be knowing it. Some of you maybe might be knowing some of the servers what is available in JPMC that costs more than 100 crores. That much specialized hardware we have. Benefit of that never fails. That is a highly reliable, that never fails. Of that costs hundreds of crores or thousands of crores, and you are storing this all data, it's not justice, because that much profit you will not get it. That's for sure. Margin only, no? How much profit you will get with the internet data? So that was the big problem. Now, do you need something better or no? You are happy with the problem. Anybody happy with the problem or need something better? Tell me. Are you waiting for something new, right? Or it's with this problem I'll store on a normal data warehouse. Even Informatica, you guys are working on Informatica. That is very costly. You know that. Informatica is very costly. Informatica licensing and all, you know that. Informatica and Avenito, and they are costly. It's not a cheaper one. It's a costly. Very soon after, Google did their own, and they have solved the problem. Actually, now I'll tell you a little backstory. Just 3 lines, not more story. Google silently did it, solutions for it. And actually, during those time, they have developed 3 white papers. First white paper was there based upon the GFS. You might have heard Google File System. The second one was based upon the MapReduce. And the third one was available with the Google Big Table. These are the 3 more advancements. Silently they did it. That was not in public during those days. They have solved the problem and they told to others, sir, you have this kind of a problem, please. Now, so Google story is different. So we'll not go in a Google stories. This one was the problem. So there are 2 great scientists. They took up the challenge individually. They were not working with it. Individually, they have taken the challenge and they have trying to solve this both of the problem. And the scientist name is called Dog Cutting and Mike Caffarella. Mike Caffarella. These are the two buddies was there, and they come up with a solution. They have developed their own solutions. And the solution name, they told it as a Hadoop. It's just a name they have given. It's just like a name of the toy. Dog cutting son was playing with the toy. Very interesting. And his son was saying that toy as a toy, elephant shape. So he was saying Hadoop, Hadoop, Hadoop. So he has made this as a Hadoop. So wherever you see the images of a Hadoop, it will be like a elephant. So they have developed the solutions called Hadoop. And Hadoop solved the both of the problem. Hadoop solved both of the problem. And they have donated it to open source. Open source, who manages? Apache Software Foundation. That takes care about all open source software. So they have developed and they have donated to this guy. When? In year 2004. In year 2004, they have solved it and they have donated to Apache Software Foundation as an open source. And very soon, open source. Within 1 year, this become one of the greatest project available in Apache. That much demand and that much need was there. Hadoop was having solutions for both of the problem. And number one, it has the solutions for both storage cost and processing unstructured. That itself is very different than the others what is existing. And number two feature is called open source, means free. अब see? What you need urgently, you can pay any money for that, but it's free. Just think. It's a free. Now everybody will think, yes, sir, there is stuff in this. Yes. So this is what we are going to have. It's a free. It's a free. So Hadoop has become free open source technology. Now let's look into it, how it has solved your problem. So this one was a Hadoop, and it was a complete ecosystem basically, Hadoop. It is having two major components. First component was talking about the storage perspective. Here it was talking about the storage, and we call it as a HDFS. Full form is called Hadoop Distributed File System. Hadoop Distributed File System. And the second one we have called processing. We call it as a map reduce. So this one was having two major components, storage and processing. Now, you know that storage is going to use the commodity hardware. It is going to use commodity hardware. Commodity hardware means it's almost no cost. I repeat, commodity hardware means it almost no cost compared to the actual servers. Like what server we were talking in 100 crores, Hadoop is saying, no, I work with the normal hardware available in the market. It's a generic purpose. Like normal 128 GB RAM and hex core processor, I'm happy. I don't need it a 1000 core CPU or not like that. Normal, it's fine. Normal, it's fine. Hadoop was designed in such a way that, and as far as the processing is concerned, it can process anything. Anything in the sense, it can be structured It can be semi-structured and it can be unstructured. All. It can process anything. And that was being already, Now here, this one was the commodity hardware and they are going to use this. So here commodity hardware means storage cost is very low. So storage cost is too low, something like this.
Manish, are you there?
I think he has some network issues.
Yeah.
Pretty much everyone is having the problem, so he's gone. And he's moving now.
All right.
Manish, we lost you for at least 5 minutes.
What break needed? Hello?
No.
Yes. So what we have, storage cost is too low, basically I'm saying here. And as far as the processing is concerned, I can process anything. Don't you think Hadoop is interesting? Don't you think Hadoop is interesting, guys? Can you confirm interesting or no interesting? Everybody keep on responding to the chat window, okay? Because if you keep on chatting, no, means it will connect you to me. And I told you I want 5-star rating, right? So for that, it's mandatory that you and me are totally connected. I will talk. Cost-wise, I will talk. Yes, I will talk in a great detail one by one. I'll break it. HDFS means what and this means what. All right. Yes, guys. Very good. Interesting. Acha, need a break also? Need a tea break as well? Or how? Yes, guys. One small discussions will do about the tea break and about the lunch break. What time lunch break is needed? And because tea break generally 15 to 20 minutes we take, not more than that. So lunch break, what time? Lunch break, what time you need? So accordingly, tea break, we will shift it.
2 o'clock will be fine, I think.
2 o'clock. Yeah, we'll just message it. So if you message, accordingly, we'll see the voting and accordingly we will decide. Whose majority will be more? I'll go with that. Okay.
Seems it's like 1:30.
Yeah. That's what voting means. Evening, nobody will complain. Yeah, it looks like 130 is majority. So ठीक है, तो 1:30 we'll take a lunch break. So right now we'll take a small break for 15 minutes, a tea break.
Yeah.
And post tea break, I'll discuss about architecture of HDFS. All right. Please have a tea break and see you in another 15 minutes. Thank you so much. Thank you, everybody. Thank you. Hello, friends. Hello, good afternoon, everybody. Yeah, I hope they are coming back slowly. All right. We'll give another 1 minute and then we will start. 1 minute just for buffer. And during this 1 minute, if you have any questions, please. During this time, if you have any questions, you can ask. If you have any questions, you can ask. All right. So since there is no questions coming in, I'll start my talk for the day. And we are going to discuss about first half, that is called HDFS. No, just a second. Yeah, don't. Yeah, no problem, no problem. Just framing it out. All right. Now, point to be noted, guys. See here. We are talking about the file system first of all. You know, file system means what? You know, file system means what? Have you worked with any file system till now? Yes, friends. Have you worked with any file system? Anybody? Have you worked with a file system? But I am saying if you have worked with a laptop, you have worked with a file system also. If you have worked with any laptop, yes. Or especially Windows or anywhere, it's fine. Yes. FAT32, yes, I have used it. Or NTFS, yes, of course. And there are many. There are many. You know what is the meaning of it basically? Ultimately, you have a hard disk. Ultimately, this is a hard disk you have in which you guys go and store your data. Ultimately, this is you have as a hard disk. Maybe 1 GB or 1 terabyte, whatever size. Achha, guys, little bit I'm going away from our agenda, but believe me, as I told, don't stick by evening. Don't ask me, sir, we have not covered this many topic. Please give me some flexibility. Believe me, each topic you will understand. That's a promise. And there are some extra things I'll give it to you that will help you for debugging the things. Please allow me for that. At least day 1 and day 2, don't see this both together. At the end of the day 3, you can see it and you can tell me, sir, this topic you have not taught. But day 1, please pardon me. Day 1, please pardon me. I teach you something extra, and that is very interesting. That is very needed. That is very needed. So we are going to talk about file system, and it's talk about FAT32 and NTFS. Ultimately, I have a hard disk of whatever size, it's fine. Maybe a 1 GB ka hard disk or 1 terabyte ka hard disk, whatever, it's not a problem. But ultimately, you have a hard disk. That's a hardcore fact. And on that hard disk, whenever you install a operating system, a file system software get installed. file system software get installed. And you know that what that system, what it does? Actually, your hard disk, it will go and do a logical partitioning into a small part. I repeat, it will just partition your hard disk. It will just partition your hard disk. Now you can say, sir, hard disk left side you have shown circular. Yes, drawing will be more difficult. So who will draw like this? Just for easy drawing purpose, I have taken this. So this is my hard disk. And the hard disk has partitioned into small equal size blocked. Point to be noted, equal size blocks. And you know how much size? 4 KB each. And each one will be having a block ID. So block ID 1, 2, 3, 4, and blah, 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 like this. Blocks will be. And whenever I want to store a file, maybe a.txt, and file size is maybe a 2 KB. So your Windows system, what it does, do you know that? Your Windows system, what it will do you know that? It will just go and calculate how many blocks do I need to accommodate your file. Now to store 2 KB file, how many number of blocks do you need? So 1 block. 1 block. So it will go and sits in your hard disk. And you know that in hard disk, I will occupy only 2 KB because file size is only 2 KB. That's all. And remaining half is going to be the wastage. Remaining half will be a wastage. If I have another file called b.txt, and this is also of 2 KB. So if I want to store, again, how many blocks do I need? Again, 1 block. It will not go and accommodate here. It will go and it will store here. Half again used, half waste. Again, if I have a third file, c.csv, and that is of 10 KB file, how many blocks do I need in this case? How many blocks do I need in this case? 3 blocks. 3 blocks. So block number B1, B2, B3. So it will go and store it. B3 fully occupied. B4 fully occupied. And B5 half occupied. This is what it is going to happen. And whenever you are going to read the file, the blocks will be fetched in the similar manner. If you see here, any file, let's see, I will show you. This is the file, Windows file I have. Let's look up properties. Say here, 4 KB. But total size is only 2.5. Size of the file is very small. But how much disk space it took it? 4 KB. In my Windows machines, I can check it like this. On a disk, you have took 4 KB. But my file size is very limited, 2 KB only. So like this. So remaining is wastage. Remaining is wastage. And whenever if I do a double click, the file will be fetched from the blocks and it will be reconstructed in front of me. So if I'm going to read it, so for a reading, let us suppose I do a double click on a file c.csv. So processor will fetch me a block ID number 3 first, then 4th, and then 5. And it will reconstruct the data. First 3, 4, and 5. And you know that these blocks are always going to be stored in contiguous memory locations. Continuous. It's not will be jumping job. One here, one there. Not like that. Not like that. All continuous. All continuous. That will be easy for reading and writing purpose. And this is what your Windows system is talking about, or this is how a file system works. This is how a file system works. If you have a question with the file system, please ask. Any questions with the file system? you can ask. This is the simple file system available. Maybe a Unix file system, a Linux file system, or whatever file system. The mechanism is the same. Mechanism is the same. Anybody have any doubt? Please. No doubt? All right. No questions. Yeah. If no question, if you keep on confirming that, I'll get more confidence. You know, I feel sometimes very scared if you guys will not speak. I'm little weak in that sense. Your support always I need in the form of chat. Yeah. All right. Next terms is talking about the third term about it. It's called distributed. So HDFS is a distributed. So point to be noted, there is a two terms I have. One is called centralized and one is called distributed. Centralized and one is called distributed. Centralized means I have a one server and everything is available in this. What is your Informatica you are talking about? Centralized. All your RDBMS or any data warehousing, whatever you know, that all is centralized. In one server, everything will be available. Everything is available in the one server. Let's take one little more break down the things. As for example, I have 100 movies. I'll keep all 100 movies in this server. That's all. Distributed means I'll be having many machines, many nodes, I can say, and I'll distribute the tasks, distribute the data among this. So I have a 5 node. Node number 1, node number 2, node number 3, node number 3, node number 4, node number 5. Guys, believe me, even though you will not do a practically this all, but believe me, concepts wise it will be transparent clear. Concepts wise it will be transparent clear. And in meanwhile, I will show once practical in my system. I will show it in my system. 5 machines I have. So this movies, I'm going to break down. Some 10 movies here, 10 movies here, maybe 20 movies here. And this one is 30, let it be 30. This is simple meaning of a distributed. This is the simple meaning of distributed. I have a set of nodes and they have distributed all my workload in this. Now, right hand side and left hand side, what do you think? Which one is beneficial and why? Which one is beneficial and why? Anybody?
Distributed is beneficially, I think, Manish, because if any one node go down, the other movies will be there. But if the RDBMS or went down, all the movies will be gone. That's the one advantage.
Yes. Yes. In multiple cases, always right hand side is going to be the better because just imagine one system failure here, 100% data loss or down, and here if one system failure only 30% is down, remaining 70% is available. That is the one scenario. Number 2, if you are going to write 100 terabyte of a data, so 100 terabyte of a data is being written here, writing will be slow. And here writing is happening here and here and here and here. So writing will be faster. Even reading will be faster. So in all of the sense, right hand side is going to be the better options. It is more fault tolerant, or we can say it is more highly available. It is more highly available. Hadoop is also going to be provide you the distributed storage. Till then, everybody was stick with the centralized. Hadoop say, no problem, I will distribute the data. And while distribution of the data, what we are talking about, I'll be having 5 nodes. You know that every node will be having some hard disk. And this is the node number 1. Node number 1. Node number 2. Node number 3. Node number 4. And node number 5. And whenever every hard disk is available, underlying hardware, it will be like this. Now you have a blocks, whatever, whenever you want to store a file a.csv and file size is of 200 MB, I want to store it. So storage is not going to be there in a one server. Basically, it's a distributed. So I want to store it here. So here, so many hard disks I have where it will be stored. Now, to manage this all birdies, I need some additional daemons or processes that can manage it. And here we have something called data node and name node that does it. So what we are going to do basically, so HDFS will divide this into the blocks, and that blocks are going to be the smaller blocks. And block size is going to be how much? It's 128 MB. It will divide into the blocks of 128 MB. Now, why 128 MB? Big data application, because of a small multi-meta information will be generated. Hard to manage it. So better, we are going to have a 128 MB. However, it can be configured. So it will be divided. And based upon this one, how many blocks do I need? So there will be 2 blocks, block number B1 and block number B2. And block number B1 will be written on this hard disk. However, block number B2 will be available in this hard disk. And to manage this all, there is a daemon called name node. Again, I'll not go in that detail because it's a different course. So name node, who manages, simple idea, it's manages. I'll not go in that detail. Who manages all the storage. So B1 will be written here and B2 will be written here. And name node manages this. And number 2, since it is going to be, earlier you have discussed, if the machine goes down and it is a commodity hardware, that commodity hardware, general purpose hardware, and that is very low in cost. Low in cost means that can fail at any time. Well, in that condition, I want my data to be highly available 24/7. I want my data to be highly available. To do so, Hadoop is saying, I will maintain replica. Replica in the sense copy. By default 3. By default 3 copies. For each block. All the time. So that if one machine gets down, I should not get worried about it. Only the one criteria, no 2 copy of same block on a same node. It's not the case. And you know that why? Because what is the point? Like B1 and B1. If I make a 2 copy on the same machine, does it make any sense, guys? Is it good or it's bad way? If I make 2 copies on the same machines, is it good or bad? Confirm, please. Is it good or bad? Yes, it's bad only because what kind of a variety? If I am talking about failure, so both the copy failed. It's not inaccessible. So it's a problematic. So that's what Hadoop maintains it. No two copy on the same machines. So block number B1 here, B1 here, and B1 is going to be 3 copies on this. And maybe, or maybe, and B2 here, B2 here, maybe B2 here, and maybe B2 here, something like this. So this is the how 3 copies of every block will be maintained so that tomorrow, if something goes fail, no worries. I have the same data available in the other machines and I can access that. I can access that. So HDFS is highly fault tolerant and it's a highly available file storage and with a very less cost. So if one copy gets fail also, I have a no problem and I can store it at any amount of a data. And number 2, there is unlimited size of the data. I can store it because of multiple machines. Whatever, there is no limitations because it's not a one machine. There are hundreds of machines. And whenever you feel that my cluster is full, add a node. So distributed is having that flexibility and that can make it totally unique than your other existing tools. I hope what is HDFS, you buddies have got the point. And point to be noted, these all blocks are written to disk for persistent storage. So it's no memory, nothing. It's a persistent storage, please, on a disk. So this is what about the HDFS. There are so many in-depth concepts are there, but we'll not go in that detail. But this much, if you know, you can manage until you are totally Hadoop, going to work on a Hadoop, you can manage with this. Now, here, there are 2 terms are there. I will tell because while doing, maybe you will get some kind of errors now. Because these are the logs you may receive. See, your training, I'm keeping in mind that you are going to help to the support team and I'm training on that behalf. So here, whenever you see, there may be possible, you'll be getting some error. Now, as I told, I have 5 hard disk, 5 nodes that are going to store my data. So name node, it's a daemon basically. Daemons. So name node is the one who is master, who stores meta information about all blocks and all data of the cluster. Please make a note of it. Who stores meta information and manages everything related to storage. Manages everything related to storage. Manages. It is the master. It is the master process. It is the master. Who manages that? Master daemons. Who manages everything in this. Everything related to the storage. Now, data node. This is the other daemon that's possible. Data node is the daemon which stores physical blocks. and respond to the malware. It's a slave process. Slave process. It's a slave process that is going to work with the instructions with the name node. So data node will be available in everybody, and that will be informing to the master that I have what and I have what and I have what. So they are going to be coordinated at this one. Name node and data node. Name node and data node. Now, if name node is there down, everything will be halted. You cannot do anything. If name node is down, you cannot do anything. You cannot do anything. Now data node are going to store my data. So sometime while recovering or any log analysis, you'll be seeing replication. And in this replications, you will be hearing about under replications. Under replications. Under replication means I was about to maintain 3 copy, but it is less than that due to some failure has happened. So if data node is not available, it will be under replications. So it means some block, some copy got it corrupted or it is unreachable. So it's called data node live, data node dead, how many replications I have, how many nodes I have, that kind of things you'll be getting here. So that will be our Hadoop storage perspective. That will be our Hadoop storage perspective. Is it clear? Yes or no? Now I'll not go in more details because more detail means it will take another 2 hours. You know, Hadoop means little tedious one. So it will take 2 hours. If you have some lighter questions, you can ask so that I can answer. Any questions from the outer side? If you have something, you can ask. Because this is a separate course. Hadoop is a separate course. But since you buddies are going to support it, so little bit I'll keep on give a glimpse of Hadoop also, because Spark is a Hadoop only. All right, so there is no questions. So this is all about my storage, and little bit you can study now. So this one about the Hadoop, and you know that Hadoop always works with its own storage, and I have its own storage that is called HDFS. The benefit of it, because it's a commodity hardware and distributed, means highly available storage. Number one, it's a resilient, because if something fails, name node itself, it will take care, no problem. And it's a distributed. Distributed means read and write will be super fast. The second part of the ecosystem, what was there in the Hadoop, it was called MapReduce. Have a look. It was a MapReduce. MapReduce was designed in such a way that it is basically a Java framework. I repeat, it is basically a Java framework. It is basically a Java framework. Basically, it's a Java framework. It was designed in such a way that it can handle any variety of a data. It can be structured, it can be semi-structured, it can be unstructured, anything it can handle. There is no problem. So Hadoop was designed in such a way that you store the data in HDFS and I will process the data using MapReduce. Now, how it was there? Like, say here, I have a data available in the 4 machines. So here I have a block number B1, I have a block number B2, and I have a block number B3. If I have a file, maybe I have a.csv, and that file is of approximately 300 MB. So you know 3 blocks will be there. So 3 blocks are available in the 3 different machines. This is the node number 1. This is the node number 2. This is the node number 3, something like this. And whenever I'm trying to process it. So MapReduce was designed in such a way that it processed the data based upon the data locality principle. Data locality principle means B1 will be processed here, B2 will be processed here, B3 will be processed here. And ultimately, in the reduce phase, the result will be accumulated and result will be accumulated here. But what B1 you have, you process here, data locality. Where the data is available in the hard disk, run it on the same machines. And that makes it very super quick. Because if you have a data in this machine and you copy to this machine and process, so copying time, maybe a 5 minutes I'm taking to copy, so my job entire performance will be degraded by 5 minutes. Because this 5 minutes simply you are wasting. 5 minutes simply you are wasting. So this is how MapReduce was designed, that it will be a data locality principles. Now, next benefit of this is MapReduce was providing parallel processing. It was designed in such a way that it gives parallel processing. That is the benefit. Parallel processing. Parallel processing in the sense, by the at a time t0, B1 will be processed at node 1 at the same time. B2 will be processed in a node 2 and B3 will be processed at node 3. So this is called parallel processing. Parallel processing. Now, don't you think it will be super quick in the processing? Because if you do the processing in the one machine, firstly B1, then B2, then B3, it will take 3 times more time. But here I can finish the task in 1/3 time. 1/3 time I can finish up the processing. So MapReduce provides, these are the benefits that is called parallel processing. Parallel processing. And this makes a Hadoop one of the super cool project of your entire Apache software foundations. So benefit, you have seen the Hadoop, right? Hadoop already, you know, there is a 2 windows we have, and HDFS and MapReduce, and both the cool feature you have seen just now. Hadoop, we have a HDFS, distributed storage and parallel processing. What else are you looking for? What else are you looking for? So this one was the cool project available during those days, and everybody and anybody can come up to this phase, and they have started liking this because of the speed of the execution and because of the low cost for storage. Data is highly available, and as far as processing is concerned, super quick because of parallel processing. So here I have just given 3 blocks. You may be possible you have 1,000 blocks. So that will be executed super cool way. And that makes a Hadoop super unique than anybody else. So this is our Hadoop. I have given a high level overview what is Hadoop all about. Now in MapReduce also I can take one example and I can go for the different phases. but I'm trying to skip it actually. I'm trying to skip it, but one question has came like this. Okay, Chiranjeevi asked this. You want, actually, I was thinking to skip it. Chalo, theek hai. I'll do it. I will explain them. Since questions has came so, I will explain them. No problem. Outer view is clear to everybody. Now Chiranjeevi have asked the questions about MapReduce. Let's do one example. One example I will explain. It's talking about, I have a file abc.txt, and in this file I have written some data. Data is called hi, how are you? Hi, how are you? Hi, how are your mom? Something like this. And then I'm simple, I'll not write so many words. Next, hi, 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 hello, hello, hi, 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 hey, something like this. And I'm just assuming that it's 2 blocks or 3 blocks, your choice. And I'm just taking maybe a 200 MB. This is the 200 MB file. Guys, up see here, this is just, I thought to skip it because this is not our curriculum. But anyway, just it will take 10 minutes, but your understanding will be broadened in this case. I have a 200 MB file, and you know that I want to store it on HDFS. So if I'll go to store.hdfs, how many blocks? Please tell me. How many blocks? Yes, 2 blocks. So this is my HDFS, and the 2 blocks will be stored in 2 different machines. You know that 2 different machines will be there. Diagrammatically, I am showing it. This is my HDFS, and where I have kept it as abc.txt that is going to manage it. And this is the block number B1 that is available on a node number 1. A node means you know that data node or any machines, you understand for that reason. And this is the block number B2 that is available. So in the HDFS, there will be hundreds of machines. Let them be there in a silent mode. My concern, I have only 2 blocks, so I have taken 2 machines. And there are somebody, so a dot, 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 I am moved poking so that they are there. It doesn't mean that they are not there. They are there. And this is my data available in a block number B1. And this is the data that is available in the block number B2. Just a silly assumption I did it. Just a silly assumption I did it. They are sitting on their hard disk. They are sitting on their hard disk. Let it be. Fine. On a fine day, some developers have asked, can you count which word, how many times are present in the file abc.txt? This is the question somebody have asked you. Can you count which word is coming how many times? How many times? Which word is coming how many times? Which word is present how many times? Which word is present? Which word is present how many times in the file ABC? This is the fine question somebody have asked it to you. Now, if this is the questions has been asked to you, what will be your strategy? Being a developer or maybe being a class 8 student, what will be your strategy? What are the steps will you do to count? Forget about the programming language. I'll give a plain sheet of paper and I'll give it to you. Can you count which word is coming how many times? What will be your strategy? Steps to solve this question. Without programming knowledge. No programming, please. Normal kiddies way. I repeat, kiddies way. Steps, please. What kids will do? If a class 6 student, if you ask, he can do that. Yes, Ankur have some solutions. Chiranjeevi have. Guys, please answer it, because that will confirm that you are there with me. A little bit you think, count one by one, Shravan, don't you think your mind cannot recall everything? Hi one, how one, and then again R1, how one. Then your mind, can it, don't you think you'll get confused? Guys, don't you think that you are a Superman? We are a normal, ordinary man, Baba. You will forget it. I know that. If I'll give you 1,000 words, you cannot do that. I know. But you guys are writing something. I will ask you. Then you'll say, sir, wait, now I'll do time. I need some time then. Guys, aram se, go slowly. And you think like you don't have a computer. You have a normal pen and paper. And I have given one big page. And I have asked these questions. Somebody told I will count it. Sir, mind, do you think in your mind you can do? Somebody is saying distinct also. Sir, distinct, fine. I have a no problem. But can you do in a one step? Your mind can do it. Acha, if you have a notebook in front of you, please take one notebook and just count and tell me which word is all how many times. Step by step, slowly. Go ahead. Slowly. Don't go in a hurry. Because in hurry, multiple answer you say, I will count it, I will do this. That's what I'm asking. Kiddies way, aram se. Many of them, they have told correct answers. Sir, first of all, it's a big page. And my memory or my brain is not so sharp. I cannot keep everything in my brain. So what I will do, I will split everything, split word by word. That is what I will do. Step number 1. I will split it, number 1. ठीक है? Step number 2, you will say, okay, after splitting again, what I will do, kiddies way. You know, if I'll give you one big basket of fruits, in that fruit, apple, banana, or it's all mesh up and given it to you. And I ask, can you count how many banana, how many apple, how many orange? Then what will you do? This is what you'll do it. Sir, firstly, split everything, aram se. And thereafter, group them. All orange one side, all apple one side, all banana one side, all pineapple one side, like that. See, kiddies way, do a software, please. Group them. Group by words. And number 3, count each group one by one. This is a 3-step process, not a 1-step process. You have to do this. Believe me, you and your kids also will do the same. It's today you start doing it. Some 10 potatoes, some onion, and some vegetable. You keep it and tell to your kids. Can you do this? Count how many potato and how many. These. Watch him. He will do the same. Firstly, he will arrange it. All onion one side, all potato one side, and all this one side. And then he will start counting each one of them. This is the easiest steps that we are going to do. Now, being a developer, we are also going to take the same approach here. So write a code. Now here I'll be writing a Java code to do the same, to do the same. Same in the sense above one. Simple. What you have written? Same steps. Write a code to do that. Write a Java code to do that. Now, in this Java code, what happens? We are going to run it on a framework called MapReduce. Code is fine. It's a framework. Framework means it's a way of execution. Way of execution. Guys, it's not a program basically. It's a platform. It's a way. It's a platform. Actually, it's a two-step process. First one is called as a map phase. The second one is called as a reduce phase. Map phase and reduce phase. As you know, mapper will start first, map phase. The guy who is going to do the map phase, we call it as a mapper, or engine or executor that does it, mapper. And this one we call it as a reducer. Reducer. Program starts with a mapper phase. So program starts with a mapper phase. Now, map and reduce was designed in such a way that it is the number of input splits is equal to number of maps. Number of blocks. Yeah, input splits is equal to number of maps. So how many blocks do I have here? 2. So how many mappers will it be get launched? 2. So this is the mapper number 1 and this is the mapper number 2. So mapper number 1 is running in a machine number 1 and mapper number 2 will run in a machine number 2. Have a look. Now in a hardcore way I am saying machine. Basically it is executor. Basically it is executor. You know that nowadays whatever laptop you have a multi-core CPU. So it means more than one processes can run at a time. But for understanding purpose, if I say machine, it will be more hard hitting. So that's what I'm saying. Now, by default, Hadoop will do something for you. Now I'm cleaning this left hand side. Map and reduce was designed in such a way that it always accepts the input and it produces the output in key value pair. Key value pair means not as a one, as a pair format. X comma Y, something like that. As a X comma Y. As a pairing format. So here for any data, Hadoop knows that it's not going to be done. So what it will do, Hadoop will read the data line by line. So here as an input, so it will prepare the input in a key value pair where keys is going to be key and value pair, where keys is going to be your byte offset and values are going to be the English line what has been given. So first line available at which position? High. 1, comma, and the English line as it is. So I'll copy it. So I'm preparing the input first of all so that MapReduce can understand it. And similarly, now byte offsets, I will just write some number. Maybe I'll say 2. Second line. But that is not correct, but for understanding purpose. I want to save some time, guys. So, but this is done by behind the scene. Number 3. We have line number 3. And now I have this state. And this is my input for the mapper 1. Input is ready. So now earlier input was available on a hard disk was that, and this will be the input that will be loaded in the memory, RAM. For the processing this data, Hadoop will load it. Hadoop will load this data in your memory. And at the same time, here also it will be done as a line number 1, and the data hello, hi, again 2, and then hi, hi, and hi, and then 3, and hey, something like this. So this data will be loaded in the memory, because what data you have seen here, that was there on a hard disk. That was there on a hard disk. And to process the data has to be loaded to the memory. So I'm trying to load into the memory. And while loading the data, Hadoop will make as a key value pair, where key is going to be the line number, and the next it will be entire line. My data is ready. My data is ready to be processed. Now, you remember that you have written 3-step process. Step number 1, you told, sir, split word by word. Word by word. Okay. So I will split word by word. So this code is my Java code, and that is my Java code which will go and run in my first step, that is called mapper space. Now, if I space it, as you know, Hadoop is going to return a data in a key value pair. So if you are saying split by the words, so for everything return the same thing won't be accepted. Something you have to return. So let's, on a better side, return 1 for everything, because I have to return in a pair fashion. So you can return anything. 1 is easy, so I'm returning 1 in that behalf. So here mapper 1 will reduce hi 1, how 1, r 1, u 1, hi 1, how 1, r 1, r1. Yes, got disconnected. Yeah, sorry, audio got lost in between. All right. Now, I hope it is audible now. So what we are saying, so during the same time, the machine number 2 will do the same tasks. So machine number 2 also will do the same. Hello, 1, hi, 1, hi, 1, hi, 1. Then hey, 1. Oh, gone, huh? Hi, 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 1. Okay. Then hey 1, and then hey. So this code will be done at the mapper phase. This is my mapper steps. Now my mapper will do this for you. So now there are 2 things are there. Number 1, 3-step process you told. So in the code, what do? You told, sir, firstly, I will split, and then you told, sir, I will group, and then third you told count. This is what you told. This is what you told. Now, first part I have done, and you know that first part I have done for each block in the every machines. Now, step number 2, what you are saying, grouping. Now you tell me, grouping, is it dependent on all buddies output or one buddy? You tell me. Grouping. I want to group all words together. So all high I want. So is it dependent on the one machine output or is it dependent on all mapper output? Over to you. Grouping. Is it dependent on one body output or all mappers? Answer please. Answer matters, everybody. Yes. So if you are answering all, then you are saying, sir, it well in that condition. Yes. If you are saying all mappers, that means reducer. That means that is reduce phase. That means it's a reduce phase. That's all. It's a map phase or reduce phase. You have to understand that. So you are saying it's all mapper. Here two are there, so all two. But in some bigger example, I have 100 mappers. So I am dependent on all 100 bodies output. So that is called reduce phase. It is the reduce phase. All right. I'm cleaning the from the top little bit. This one, clean it up. This one also clean it. And this one, take it up. Now it's a reduce phase. So reducer will be running in some machines. So I'm saying this is my reduce phase that is running in a node number maybe 12. And this is my reduce process is running. Reduce phase is going to run at this machine. Now, all mapper output will be transmitted to the reduce phase. Come here. And you also come here. That's all. I'm going to write this. All mapper output will be transmitted to reduce phase. Wherever it is running in the cluster, you know, I have 1,000 machines. So wherever it is running, it has to go. So it will travel physically on a network of your Hadoop and it will reach to the reducer. I hope clarity is coming. So this body will travel from here, control C and control V. You come here. It has came. And this also you control C and control V. You travel. So they are traveling now. They are traveling. Come, maybe here I'll write. They have traveled to the reduced machine now. All right. And then this also you delete it. I hope it is no questions coming till now. So now the data has been traveled to these machines. And now the data is available in the reduce phase. Reduce phase, it's a 3-step process. I repeat, reduce phase is a 3-step process. Step number 1, it's talk about shuffle. Shuffle. Step number 2, it's talk about short. And step number 3, it's called about the reduce. Shuffle means it's a group by key. Sort means ascending order. Sort means it's an ascending order. So firstly, talk about this. Group by key. And you know that my data is available in a paired fashion. Always. My data is available in hello and 1. Or maybe a comma 1, whatever. So hello 1. So it's going to be key and value. So what is the key? Key is hello and 1 is the values. So group by key. And point to be noted, Hadoop will do it for you free. It's a free. Hadoop will do it for you. No code is needed from your end. Being a developer, it's not needed. Hadoop does it automatically. Now, it means all words will be together. So all hello will come at together. So I'm writing hello and below 1. So below so much space, so I'll write in a single line. How many hello is there? Hello 1, then comma, then 1. That's all. If I do a mistake, please help me. Hi. Hi is coming 1, 1. 1, 2, No. Yes. If I do a mistake, either you pardon me or you help me, because that much concentration who will put? Hey, 1 1. That's all. Then how? How? 1 1. That's all. Your 1. Mom 1. Next R 1 1. R. Anything else I'm missing, or it's fine? Am I missing anything? This is the grouping. I did it. Group by key. That I did it. All words together I have grouped, and that is nothing but called shuffling. And that will be done for you free of cost by your Hadoop. So Hadoop will do for you free of cost. Over to you. Either you confirm or you can ask your questions. Or if I did a mistake, please help me. Yes, guys, this is shuffling will be done on your behalf by your Hadoop. Once shuffling is done, Hadoop automatically will short it free of cost again. It's free again. Sorting, ascending. So you know that ascending means firstly R will come, because ascending order A is come first. Then after hello will come. I am arranging the same thing. Hello, then hey will come, then he, and then hi will come. Then how will come. Then your mom will come, sorry. Mom will come. And then your will come. This is the data Hadoop will do for you free of cost. And again, coming back to your code. So what code have you written? You told step number 1, I will split. Step number 2, you told I will group. That Hadoop did it favor to you. And you told count. So this is a Java code you have to write. And that is nothing but you have to do in reduce phase. Write a code. So count. Java code for count. Java code for count. You have to write it. So R, how many times? 2 times. Hello. Hello. 2. Hey. 2. Hi. 3. I hope 8. 3, 5, 8. Yes. How? 2. Mom 1. And then your 1. That's all. And this output will be produced. And output will be written to the HDFS finally. Output will be written to HDFS. Output will be written to HDFS. That was designed pattern only. It will write the output to the HDFS. And this is the how entire MapReduce works among the multiple machines and gets aggregated, gets accumulated in the one machines, and that machine will write your final output. I hope it is clear. If you have any questions, please. Yes, my dear friends, over to you. If you have all questions, please, over to you. Some time is there. I can take some questions. No questions? Hello, friends. All right. Performance.
How is the performance? I mean, when it comes to
It's better only, no? Parallel processing is happening.
uh, I'll put this. I'll put it another way. See, Teradata also supports parallel processing, but currently Teradata, it's like we are moving towards this Hadoop and other things because we are seeing some kind of performance issues with Teradata. I mean, though it supports the parallel processing, how Hadoop HDFS is more superior to Teradata in terms of this handling in performance as well as file system handling.
No, HDFS is only for storage. They will not process the data. For processing, we have a MapReduce. HDFS only for the storage perspective. That is already cost-wise, storage is almost 100 times or maybe 1,000 times less cost you are going to pay for storage. HDFS is for storage, not for processing.
Yeah, got it.
Yeah. So HDFS for this one. Now, Swati Priya have a question. So MapReduce perform same steps on all the data we stores in the. Is it consume more time? 1 minute. So MapReduce performs same steps to all the data we store in the data.
So whatever you said, right, it will sort all the data and the count.
Yes.
Right. Shuffle sort. Right?
Yes.
Yeah.
Yes.
So if we do this all the data in the nodes, is it not consume more time?
1 minute. 1 minute. Little bit framing the question. It is going in other way. See, 1 second. Not all data of all nodes. Don't forget that it is HDFS and I have a terabyte data. What data you are processing? It's my data. Manish has kept one file and file is called abc.txt. So I'm talking everything related to abc.txt. What is happening only about this file, whether it is a sorting or shuffling or grouping or list, only about this, all blocks of this file, this file, number one concern, not about all 1000 terabyte, not about this one. I'm just talking about two blocks, what was related to my data. First concern. Second concern, in this condition, you have a simple operations called count. That's all. But do you think your life will be so easy and always you are going to do a count operations? Of course not. Multiple times you go for a join operations. Multiple times you go for a filter operations. And there are so many other operations you want to perform. Now you tell me, if you do a join operations on a sorted data and unsorted data, which one will be the faster? You tell me. You do a join operation on a sorted data or unsorted data, which one will be the faster? Or I want to do a filtering. You do the filter on a sorted data or unsorted data, which one will be the faster? Please answer, my dear friends.
Sorted data.
Sorted data. And due to that, we are making it, this sorting, it will take some time. I know it will take some 2 minutes time, or maybe some 10 seconds it will take it. But this 10 seconds will help me for all here. It will help me here. And that will be great help, not a small help. Because joining is a messy operation that takes days together if you have 1 terabyte of a data. So better you short it so that next further operations, it will be super quick. Super quick. I hope I am clear. Yeah, Swati, is it clear? Great. Great, my dear friends. Anybody else have any questions? Please. So in count operation, it's fine, but you know that anytime sorted means it will be super quick, super fast. Operations will be done super fast. All right. So this is the how your map reduce works, and that will be having a parallel processing that is going to happen. Now, one questions was there related to the Teradata. Give me some time, maybe post break. I will break that ice with the Spark, and then I will ask, is your Teradata supports this? Then you'll say no. Teradata supports your parallel processing. I know that, but not at the scale what your Spark is going to do. Not the scale at Spark is going to do. All right. Any other questions, please? My dear friends, please ask it. Hello, friends. If no questions, at least give the confirmations. Those who don't have a questions, please write in chat window.
I think Sudhakar has posted a question regarding the number of reads and writes that will be decreasing the performance, right? So
sorry. 1 minute. Number of read and write into the disk will be more. Performance will degrade even though process is there in parallel. Yes, of course, that is true, but it's not along with the here, right? How much more read and write happens, of course performance will be degraded. I agree, but without that there is no room, right? Without that there is no room. You have to do it if you want to write it. See, I want to store one movie in my laptop. I know if I keep on writing, my performance will be slow. But what to do? I want it. So you have to. You have to. No, see, you guys are a little confused. See, there are two things you are talking. Number one, you are mixing processing versus the storage. There are two things are there. One is called storage and one is called processing. You are mixing it both together. Storing means store a movie Bahubali. Store a movie. Processing means play movie. Play the movie. So I will store it, but I will not play it. It's fine. So this is going to be your hard disk. And playing the movie, this is going to be your memory. This is going to be your memory operations. Point to be noted. Processing happens in the memory. Now you can say, why movie example? Sir, your HDFS or whatever your supercomputing also. Same. Storage, HDFS, processing, memory. Processing, memory. And just now, whatever I have explained, that we have explained about the processing part, not about the storage part. Only the step number one, what I have explained, you remembered. I told B1, B2 are available on a hard disk of a machine 1 and machine 2. And from the hard disk, I have loaded into the mapper. And at that time, I told I am loading in the memory. I told it. And thereafter, I am processing. Thereafter, I am processing everything. And again, final output I am going to write on HDFS. This one, see here. This is my final output, right hand side. So final output I will write on HDFS. So I hope questions are getting mixed with the storage and processing both together. Please keep it both separate things. Maybe somebody has kept your data 1 month back and developer will write a code after 3 months. Okay. So these are the two separate concepts, storage and the processing. Maybe I have 100 files, but I am processing only the file number 1. Okay. Sudhakar. Hello, Sudhakar. Hello, Sudhakar. Hello. Sudhakar, are you there? All right. Yes. Any other further questions, please? Any other further questions, please? Kindly confirm, guys, so that we can go for a lunch break. Many of my friends are waiting for lunch. Yes, one small confirmation. All right. So there is no questions coming in. So we'll take a lunch break for 1 hour and we'll be meet at 2:30. Thank you. Thank you very much. We'll meet at 2:30. Thank you so much. Thank you. Hello, everyone. Hello, everyone. Yeah, already they have returned back. Yes.
Yeah, right.
All right. Just a second. I'll put my charging and we'll start. All right. So everybody has returned back. Now it's a time to, we were discussing about our Spark. So now, yes, MapReduce already we have seen. Now try to see here what next. Everything was in line with this, and everything was Hadoop. Now this one was your Hadoop, and it was having two things. One box as going to be your HDFS that will be used for your storage, and the next one was a MapReduce that was used for your processing framework, and it was very happy. Later in time, to manage the entire processing, because so many machines was there and they were able to do, so a third component has been introduced here, and that is called as a cluster manager. We call it as a yarn. Tomorrow I'll be discussing what is yarn, maybe tomorrow or maybe first half or second half, based upon the conditions. Yarn. So it is nothing but the cluster manager. Cluster manager. So what is the use of your cluster manager? So that is going to manage your resources for your execution. On an outer level overview, I'm saying here it is a node I have, and here also I have a node available. And you know that in every node we have a processors and we have a executors. We have a executors everywhere. We have a RAM everywhere. We have a CPU cycles everywhere and all like this. Now, who will decide which machines will be having running mapper and how many mapper will be running in which machines? Getting my point. So what I'm saying, which machine will execute and how many mapper will run in which machines. So that will be decided by whom actually. So in a Hadoop first version, it was given by the reservation system that was called job tracker and task tracker. In a Hadoop second version, yarn is the one which is going to take care. So yarn job is that. So we call it as a resource manager. We call it as a resource manager, which is going to do your job. Resource manager. Resource manager. All right. Now, in this resource manager, what we are talking about, it will manage the entire cluster resources. In every machines, how many number of core CPU will be executed for your job, and in the same one, how much will be given it for my job, and for how much time, for how many CPU cycles. So that one was our Hadoop. That one was our Hadoop, and everything was going cool actually. Again, from 2005 onwards, everything was becoming for any one-stop solutions for all your big data problem. For all your big data problem, there was a one-step solutions. There is a one-step solutions, and solution name was called Hadoop. Everybody was using Hadoop. Everything was fine. Again, approximately in year 2000 and during those times, I'm saying, again, new kind of a analysis has came in a market, Now you are hearing everything very in a great detail called machine learning. Machine learning kind of things. You might have heard it. You might have heard it. So in approximately 2010 onwards, we were having the things called machine learning. And this all machine learning problems was all iterative process basically. Iterative process. What is the iterative process? So iterative process means it's just like a process which calls itself, just like a recursion. You know recursion, like that. So let's take one example. I'll cut this one from here and I'll paste it afterwards. Try to see here. In childhood, we have played one game. Every one of us has played. That is not a problem. It's a simple running race game. There is a 400-meter race. There is a 400-meter race. And here, this is your finishing line. Finish. This is the simple game you have played. And similar to that, we have played a game like this. There are 4 members available from the same team. They all belongs to the same team basically. All belongs to same team. And everybody is going to run some part of the race. And this guy will going to finish the race. Finish. This buddy will start running. He will run for 100 meter. This will run for 100 meter. This will also run for 100 meter. This will run for 100 meter. And this will also run for 100 meter. Yes, the name is called relay game. Very good. The name is called relay game. Relay game. Now, the question I'm asking, what is the difference between these two? What is the difference between these two? What are the differences among these two games? Please think aram se, careful. You have to understand this. All right, moving further. Okay, it's got idea is clear. Everybody is getting the same. Sharing the resources, not resources. There is here, this is the one game. This is the one game. And here, can I say it's a 4 game or one race? It's a one race. That's all. But here it's not the one race. This is the race number 1. This is the race number 2. This is the race number 3. And this is the race number 4. Can I say that? This is the 4 different races there, because everybody has to start from some place and he has to run for something and he has to pass. Only the things here, the guy who is starting, he is finishing, and here you are doing one race and then you are passing the data to the second buddy, and second buddy is dependent on the first buddy. Second is dependent on first. Same thing here. The third one is dependent on the second. Dependent on the second. I hope you guys are getting my point. Similarly, here the fourth buddy is dependent on. So the first one is independent, but here it's not an independent, it's a dependent process. Dependent process. Now the question, it's a relay game. Can I say that, Acha, in this second example, do you think all bodies will start running in parallel? Are they going to run in parallel? Please answer. Are they going to run in parallel? No sequential. Point to be noted. They are going to run in sequential, serial manner. They are going to run in serially, not the parallel one. Point to be noted. And this is the 4 race, not the 1 race. It's not the 1 race. Can I say that race 1 and then below race 2 and then below race 3 and then below the race 4, and one diagram I'll draw like this, and arrow I'm drawing that who is dependent on whom. This is the process is going to happen in the second condition. This is the process is happening in the second condition. And this is called a relay game. In technical term, can I say it is iterative process? Can I say that it's iterative process? Yes, guys. Can I say that it's an iterative process? Iterative, one within the other, iterations. So it's an iterative process. Now I'm trying to clean this diagram. Now try to see. This is my data. This is here my data I have, HDFS. And here I have a data called a.csv. And if you have a one job that earlier, before the break, I have explained, I was having one job. This is the job number 1. So what you did, I have taken the output input and I have processed it and I have dumped the output here. This one was the output. This is what you have seen in just before the break. I was having the data. How many blocks let it be? That is a concern. Or you can say I was having 2 blocks. Okay, so 2 blocks was there. Fine. So that got it loaded in a 2 different machines, and 2 different machines have processed it. Then I have calculated, and thereafter final output gone it. But this is the simple steps was there. From here, I have loaded the data in a memory, and then from the memory, final output was being written to HDFS. That was the actual scenario how MapReduce was designed. Please confirm, yes or no. This is what you have learned before the break. Now, one second. All right, guys. If iterative games I am talking about. Now here I have a.csv. Now in the case of iterations, I have a 4 games or 4 race basically I'm trying to say. So I'll take 4 race or 4 job basically. So this is the job number 1. This is the job number 2. Guys, pay attention because very crucial things I'm going to discuss now. But slowly I'll discuss so that you buddies will be crystal clear. Now, firstly, data will be loaded into the job 1. Job 1 will be processed, and if it is a MapReduce, it will go and write the output here. That is the normal MapReduce program. This is the output. I'll say like this, output number 1. It will be done. Now, again, the same output will be read as an input to the second job, and this body will write the output here. And this is going to be output number 2. And again, same output is being read by the third job, and the job 3 will execute and write the output here. So this is the output number 3. And this output number 3 will be read by the third, fourth job as an input. This body will process, and finally, this is the final output will be written into HDFS. This is what we have learned before the break. How MapReduce processes the task, I've explained during one iterations case of example. In case of relay game, this is what it is going to happen. Yes or no? Please confirm. This diagram is, have I prepared it? Now you may be possible that, sir, but in relay game, we are passing the output. Correct. You are passing the output one body to other body. But MapReduce cannot pass it. MapReduce was designed in such a way that it will go and write the data to the HDFS. And then if somebody wants the same output, you read it again. Now, try to see here. I am just assuming that reading data from HDFS to this is going to take 1 hour. And just for easy calculation, I'll take every time 1 hour. Writing 1 hour, 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 writing 1 hour. And this job maybe is taking also, this is also taking 1 hour or whatever, it's fine. Maybe this job is taking 1 hour. Now, in this kind of a case, total time taken for my job is how much? Total time is going to be how much? How much time it is going to take totally? So 1, 2, 3, 4, 5, 6, 7, 8. Total 12 hours. 12 hours I need to finish my job. This will take total 12 hours to finish my job. Because your entire race, many of the people are saying it's 8 hours or 4 hours or whatever. I'm asking entire race I have to finish, guys. So race has started with the job 1 and it is going to finish the job 4. Then my job will be finished. Then your task is getting finished. So total how many hours are you going to spend? Total 12 hours. It's difficult. I'll take another example. Leave it. Let us suppose you have started a trip from here to Mysore with your car, and you started driving your car with a speed of 120 km per hour, and you have drove for 1 hour. Your speed is this much, 1 km per hour, and thereafter, after 1 hour, you have taken a break for 1 hour. So total travel you have traveled 120 kilometer. So actually you have drove only for 1 hour, but in between you have stopped for a breakfast and you have taken a break for 1 hour. So what is your average speed? It's going to be 60 kilometer per hour. People will say you have drove with the 60 kilometer per hour. They will not say, oh, you are Superman, guys, you are 120 kilometer per hour. No, no, no. Because break hours also will be taken into your journey time. Break also will be taken into your journey time. I know you have drove with a very huge speed. I know that. But what about the break? What about the break? So that is create a problem. Now, my dear friends, have a look. Now, here in this case, total time I'm going to take, it's at 12 hours. Now, it's a 4-step process and it took 12 hours. Now, don't you think, if I'll ask, what is the actual job execution time? So you'll be saying, sir, no, actual job execution though happening only for 4 hours. That's all. Actual only for 4 hours. Or maybe you can add 2 hours because first time I'm loading the data and finally I'm going to writing the data. 6 hours you can say overall. Or only execution 4 hours you can say it. But total time you took it 12 hours. Overall, don't you think you are not getting better deal, better performance you are not getting in this case? Yes or no? Overall, you are not getting a better performance in this case. And it is just, don't forget, it is a 4-step process. What about if I have a 100-step process, 100 steps iterations? if I have 100 steps iterations. So if you have 100 step iterations, you just think how bad performer it will be. Just think aram se. Take your time and please feel it. Please feel it. Over to you. Yes or no? Performance getting degraded? Yes or no? Please confirm. In this case, I'm not talking about standalone running race. I'm only discussing about relay game. I am just talking about relay game. And in case of relay game, if it is a map reduce, this is going to be a problematic scenario. This is going to be problematic scenario. And there are a team called machine learning guys. They were using normal platform and their jobs was all iterative jobs. So they fed up with the speed of their framework, what they were running. So they have inquired in the market. So somebody told, hey, why don't you use Hadoop? Because that provides parallel processing that will be really good for you. So machine learning guys came to Hadoop and they have started running Hadoop. So since their jobs was iterative jobs, this is what I have drawn. And even this guy will say, hey, all other my dear friends are saying Hadoop is excellent. But in my case, it's not. In my case, it's not. This is the comment what they made it. And it's not their fault, it's your Hadoop only. See that there nobody is telling lie. Other people are saying, yes, Hadoop is very good, cool, and all super fast. That's true. That's true. But in case of machine learning, in case of iterative processing, instead, I can say a machine learning is just a one domain. Overall, you can say iterative processing. So whenever you are talking about iterative processing, map reduce was slow. Performance was too much bad in this conditions. Performance was too much bad in these conditions. And they were not happy with the Hadoop. Anybody who are running iterative jobs, they were not happy with the Hadoop. They were fed up with the Hadoop. They told Hadoop is quite good for others, but not for me. Not for. Now they were looking for some better deal. And as a resultant, a new framework has been developed. Compared to MapReduce, a new things has been developed to make a speedy nature. Now you tell me, do you have a better plan than this? Do you have a better plan than this? Anybody? Yes, guys, anybody have a better plan? Or no plan? Oh, nobody, yeah? No plan. Yes, guys, no better plan? How can I speed up basically? How can I speed up? Nobody has any solutions? No, not
We
parallel.
should come out of sequential, I think.
No, not parallel. Parallel, though it's fine. Parallelism is there, Baba. But many of them, they are saying parallel. In relay game, if you will start running and your friend also will start running, then is it your... How relay will finish? Why, dear friends, please listen. What I am saying. It's a relay game, right? So relay game, if you start running from here and your friend also will start running here, then what? You have to pass the flag, na Baba. Until you give a flag to him, if he will start running, what kind of a race it is? It's not a relay. Relay game means what you have. You have a flag, right? So you have to give the flag to him. Flag to who will pass the flag? Then if everybody will start running parallel. So this parallelism not possible at all. Relay means
Instead of hello,
Mhm.
hello.
Please.
Yeah, instead of writing the output 1, 2, 3, directly the output of the job 1 can be passed to job 2, and the output of job 2 can be passed to job 3. And the
Yes.
final output will be written at 1.
Yes.
Yeah, true.
Don't you think if I just pass this from here to here, and from here to here, and from here to here, it will be this 2 hours I can save, this 2 hours I can save, and this 2 hours I can save with a zero time. Because here my data is available in the memory. Because whenever data gets processed, data will be there in memory. And here in job 2 also data is getting loaded to the memory. So you are trying to pass the data from memory to the memory. And you know that that is a super quick operations. So if I do this 2 hours, 2 hours, and 2 hours, that 6 hours can be reduced with just 6 minutes or even less than that. The 6 hours, whatever you are saying, that I can reduce. 6 hours that I can reduce it just by passing the data from memory to the memory. Passing the data from memory to the memory. 6 hours I can reduce. 6 hours I can reduce it. And that makes it super cool basically. Well, in this condition, total time I'm going to take only 6 hours. And that was the drawback of MapReduce. And what just now you buddies have told, that to develop, they have come up with a new plan and they told it's a Spark. It's a Spark. So why Spark was needed? What was the need? And what is the use case? What was the use case? That everything done. So this is what is talking about the Spark. So MapReduce was designed that it cannot pass at all. So they have developed it. They have developed it. No, we will talk about how much memory and all. Just introduction I'm doing. So don't go in the depth. We'll see slowly. Now this is what we are talking about. Spark is going to do that. So Spark is well capable of do that. However, MapReduce cannot. MapReduce cannot do the memory mapping for a data from here to here and here to here and here to here. Now, here, little bit try to see, guys. This is what they have developed, and they have told it's talking about the Spark. And point to be noted, the moment I told it's a Spark, now you know what is going to be the Spark. So is Spark is going to be your entire Hadoop? Can you tell me? Is your Spark is going to be entire Hadoop? No, it is just for MapReduce. That's all. So it was earlier it was a MapReduce, and people have come up with a new idea, and that is called Spark. So Spark and MapReduce is the competitor, not the Hadoop with this one. So Spark also it is a Hadoop family only. So MapReduce, it is going to write the data. Spark can transmit the data to the other job. So this is the one outer view of the Spark. What is Spark? Now, you will be thinking, sir, I have learned before the break that MapReduce is going to do parallel processing. So what you have drawn in the diagram, there is no parallel processing. I repeat, before the break, I have taken almost 15-20 minutes and I have explained what is mapper and reducer and parallel processing is happening. So that all gone. There is no parallel processing in this diagram. Any comment, guys? Any comment?
No, here also we have the parallel process. Hello.
Yes,
Manish?
I'm listening. I'm listening. I've become silent so that everybody can speak.
Yeah, here also
Sorry,
we
can.
have parallel processing. The job one which runs it in parallel.
Yes. Very good. Guys, before the break, you remembered I have taken example of a job, one job. And in that job, I have told this is my job. Maybe this is a word count job. Job name, I'll write it as a word count. So word count for input file. So what is the file you have? A.csv. So in that job, there is a two blocks are there. Correct. So this both the blocks was running in parallel that you have seen that. So this block number B1 and block number B2, and that was running in a machine number 1 and machine number 2. So let them run it. And then same way here, job number 2 also. So how many blocks will be there? Accordingly, I am saying here, final output block number 1 from machine number 1, you pass to job number 2, and this is going to be machine number 10 and machine number 11. So what data you have, you pass it to this body and I will pass it to this body, memory to memory, in different machines, distributed manner. And then again, M10 and M11 will be done in parallel. And similarly, after doing all the processing, what M10 have, it will transmit it to the M100, M machine number 100 and machine number 101. And then what 100 they have, that way it is going to do it. So here within the job, I repeat, within the job, I have the parallel processing, not across the job, please. That is number one. And my dear friends, please pay attention. What I am saying, my job number 1 was running in a two machines, machine number 1 and machine number 2. And machine number 1 was available in the memory. How many blocks? One block. So basically, how many memory? 128 MB. And this one was the 128 MB. And that was, I am trying to pass from one machines to other machines. It's not about 1 terabyte in the one machines was there, and I'm trying to pass 1 terabyte from one machines to one machines. Point to be noted, guys. What I'm saying, I am not saying that your entire 1 terabyte available as a file and that file you transfer from one machines to other machines. I have a small chunk, and that chunk I am trying to pass from one machines to other machines. One block I am trying to pass it. Now, point to be noted here, in all of these cases, I am trying to pass the data, or to pass the data, you have to cache the data, because data has to be there in a memory. Output has to be there in a memory. So I'm caching the data and I'm trying to then pass the data from here to there. Now, many of you before the break, you told, sir, in our Informatica, I can do the caching. I can hold the data. I can cache the results. True, but can you cache at distributed scale? That question is that. Can you scale it like this? Can you do this caching? You hold it in this machine, I will hold in this, and then from machine to machines, can you do that? That feature, is it available in your Teradata? Please. Or maybe Informatica, or maybe Benito, or whatever, guys, please confirm. This caching at the distributed scale, do you have that feature? I know your Informatica or Teradata that has a feature for caching that can cache the results. Correct, but that was a centralized label altogether. As a whole central label, I am doing it. But here I am talking about the distributed scale. And even data is transmitting over the distributed memory to memory mapping from one machines to the other machines, one executor to the other machine. Does this feature you have in your Teradata? Please confirm. Please confirm. Oh, no answers. Hello, friends. Hello, everybody. Hello. No response is coming. Is this feature available? Please confirm. Only one body is responding. That's all. Basha has responded very early. Others, my dear friends, please. This feature, you don't have it. Yes. And that makes it really unique. I repeat, that makes it really unique. Completely unique it makes it. That feature does not have anywhere what you are thinking. And that is the beauty of your Spark. That is the beauty of your Spark. And now I will clean this diagram. Now you understood what is Spark as an outer views. So now your Spark also, later in point, they have joined the same family. And earlier it was a MapReduce, and then it is going to be Spark. So this is my Hadoop. This is my Hadoop. Earlier it was a HDFS for storage, Yarn for the cluster manager, and MapReduce for your processing engine. Now you have the Spark. So either or, I will say. It's a Hadoop. So now this is the benefit of your Spark that makes it super unique compared to anybody else. So what Hadoop was having, that's true, and Spark is added advantage over the top of the MapReduce. And I have just shown you one added advantage. Believe me, till tomorrow evening, you will be seeing, oh my God, this also, this also, this also, this also, this also. So that is how beneficial it is. So that's why Spark is going to be like this. Now, Spark is going to do everything is in memory. Everything is in memory. And that too at the caching, in memory, caching, and at distributed scale. It's at the distributed scale, basically, not at the central scale. That is makes it totally unique than that others. And that makes it in memory, of course, it's going to be fast. And research says that it's almost 100 times faster than MapReduce because of multiple regions. And you have seen one such region that I am just trying to transfer the data from a memory to the memory. And that makes almost 100 times faster than the MapReduce. Number two, MapReduce writes all intermediate results to local disks. MapReduce writes all the intermediate results to the disk. However, Spark writes in memory only, in memory. So don't you think, oh my God, internal results also in memory? Of course. By listening to these two words, you can say Spark is going to be Spark is memory intensive operations. I will say on a lighter note, yes, memory intensive operation, yes, but not how much you are thinking, but not exactly how much you are thinking. How much you are thinking. Why? Because I'll explain you afterwards within 1 hour. It's a memory intensive, that's true. I'm not denying it. But how much you are actually thinking, not that much. It will take some time to understand that. It takes approximately 1 hour to understand that. So it's a memory intensive, that's true, because everything is memory. Even buffering is there in a memory. Even buffering is there in a memory. Caching is there in memory. Everything is in memory. Means once data will be loaded to the memory, it will be not kept anywhere else. I repeat, once the data will be get loaded to the memory, it will be not kept anywhere else. It will be there in a memory until the final results comes in. So relay game example, the data will be loaded once to the memory, and thereafter all the data moving and all everything will be happen memory to memory to memory to memory to memory to memory to memory, and then final output to the disk. It's not about memory to disk and disk to the memory, not like that. And even not to the local machine also, not to the local machines also. That makes really super cool. That makes it really super cool. Super cool. And that makes a Spark really unique feature. That was really great. And I hope you got the impressed with the Spark. Yes or no? Have you got impressed with the Spark now? Okay. Saurav is saying not yet. No problem. You will get, no worries. Yes, feel free to discuss. If you are saying not yet, then also no problem. No problem. But at least one feature what you have seen, Saurav, it was not interesting? One feature you have seen that, right? That was also not, because that was the root cause and that has not impressed you? Mm-hmm. Rafi, just give some time. Don't go in a questions mode. Sometime you give it to me. Yes. Saurav, still, hello, Saurav. At the zero, that features what I have shown, even not 5-10% also? Kind of. Okay. Take care. Yes, yes, of course, I will show you. But the major things what I have told, that was not simple things what I have explained. What was you have seen the relay game, it was not a simple things. What you have seen, this is not impressing. It was not a simple things. It was a great things that can be possible. And believe me, none of the features till now available that provides it. That was the one such features that makes it Spark totally unique. That makes it totally unique than anybody else. Anybody else. That itself was too much different and too much unique features was there. Now, next is there Spark. As you know, MapReduce was written in the language called Java, and it understands only Java. That's all. Only Java, please. So any developers who wants to work with a Hadoop, they have to learn Java. That's all. But not with a Spark. Spark was written in the mother tongue called Scala. It was written in Scala, but it speaks multiple languages. It speaks Java. It speaks Python. It speaks R. It speaks SQL. Now you tell me what are the languages it is available right now in the market. Don't you think, oh, any language and you are all okay to work with a Spark? Any language and you are all done for the Spark. Spark doesn't ask you to go and learn this language and then you come to me, then only you can use it. It's not true. Spark can. Spark can do this. Spark can do this. So this one was another cool feature about, this one was having cool feature about the Spark. One such, again now, impressive or no? At least this feature. It's a cool feature, yes or no? Any language and you are all done. It's not necessary that you must learn anything. This is again another cool features. Next. Spark is a framework that is having the Spark core engine. Spark core engine that can be used for all your Spark normal processing, whatever you have, normal Spark RDD processing, it's fine. If you have a Spark SQL, so there is a framework available called Spark SQL, and that can process your data with a SQL framework. Alone Spark does it. It's not a translation. If you are working with a machine learning, Spark core engine have its own library, own API called MLlib that supports it. If you have a graphical analysis, so it is having the library API that is called GraphX that supports it directly. So Spark alone can support you the variety of use cases that can be possible. So you see the domain that it can support. You are working in a machine learning, it's fine. You are working for a graphics, it's fine. You are working for a normal SQL applications, dataware, it's fine. Or you are working for any applications, API development, it's fine. Spark is all there for you all. So Spark makes it so easy for you all by seeing this feature. Impressive now at least? Yes or no? So alone Spark is able to do this, and that many versatility you don't have in any other things. Neither even your Teradata also does not have it. So morning only I told, so that point only you can stop it, that big data applications, and that too it's open source. So that silly things only can make it distinct. No, that is different, this is different. It's a complete new globe. So this is how your Spark makes it cool about the features that makes it really interesting and fast. So yes, now a little bit, Saurav. Now a little bit. Much better than earlier. Yes, there are so many things are there. Don't worry. Still time yet to come. Now at least, guys, impressive. Spark is impressive now. All right. Yes, guys, it's post lunch. Some more energy we want from you. Impressive, right? Yes. Now it is more impressive now. Now if you hear, no, you'll say, oh my God, this is what fake. Now try to say here. How come Spark is fast? If you'll go on a Google, and just look for Spark homepage. I will share the link to you. Just give me a second. Spark releases. Maybe I'll go on a release page. Yes, Spark page. I will share the link to you. This is the home page of the Spark. And if you see at the bottom, see, this is also machine learning only. Logistic regression, it's a machine learning. In a Hadoop and a Spark, MapReduce and a Spark, they have just shown that how fast it is. So they found it approximately 100 times faster. 100 times faster than the 110 and this 10. So Hadoop is going to take approximately 110 seconds, and Spark will just take about 0.1 second. 9 seconds. Approximately 100 times. It's written here. 100 times faster than your existing one. It supports all the APIs. And it is just going to be a unified analytics engine for large scale data processing. It's unified engine for large data processing. And below, if you go on a home page, you see here just now what I have shown it to you. Brief before that, Spark contains and which is having a separate library, separate APIs for all. Spark SQL, Spark streaming, I have noted streaming applications. In Hadoop, there was not streaming. Machine learning, graphics. So this one was a cool feature that makes really great. And next things, Spark can be integrated with all major technologies available today. I repeat, Spark can be integrated with all major technologies available today. It can be connected with a Cassandra or HBase or Mesos or Hadoop or maybe Kubernetes. So it can be done with that. So this is the home page, and I hope it has given you a complete brief what is going to happen. Now, Spark is just a execution engine, which is having execution engine that is a Spark core, and it comes with a 2 plug and play basically. I repeat, it comes with a 2 plug and play. What was the 2 plug and play? Number one, it's talking about the storage system, and number two, it's talking about the cluster manager. Storage, you know that Hadoop always works only with HDFS. That's all. I repeat, Hadoop only works with HDFS. Apart from HDFS, sorry. But Spark says, I can work with HDFS, no problem. Or I can work with a local file system. If you have a data in local, I can. Or if your data is available in Cassandra, I'm okay. Or if your data is available on EC2 or Azure or wherever, Azure Data Lake, or anywhere, it's fine, no problem. Or Spark is saying if your data is available in data warehousing or RDBMS, then also it's fine, no problem. And it can get connected with other sources as well. You know Kubernetes Melo. So Spark can work with variety of storage. It's not only limited to HDFS. And as far as a cluster manager is concerned, by default, it is having a cluster manager called standalone cluster manager. Standalone. Similarly, we have Yarn as a cluster manager, though who are coming from Hadoop background, and a new tool has been developed right now by Yahoo and Mesos. I'll not be discussing about the Mesos. I'll be discussing about the Yarn in my training. 1 hour lecture I'll be taking on Yarn. Mesos I'll not take because both are the same competitor. So Mesos is very quite new and young. Yarn is very popular and very old. And in almost all Hadoop things uses Yarn. So I'll be talking about Yarn and Stand. So Spark is having this much apart from other features. Now that also makes it totally unique than the anything else that possible. Please have a look. And if you have any concern, please raise. Now at least you got at least convinced. Spark, is it impressive now at least? Looks good. But believe me, there are so many things yet to come. Don't worry. Spark is like that. Keep on speaking, and they'll say, oh my God, this is also. Yes. Still, I have not discussed about the Spark. This is just outer marketing point. That's all. Inner architecture, though, I have not discussed at all. I'll discuss now. So I hope now you got little bit idea about what is Spark. Now you have seen your Spark and you have seen, sir, it is going to be 100 times faster or something like that. What makes it so faster? Can you little bit put a point on this? Yes. Let's talk about why it's faster. How fast? Now, so to discuss it, I'll take some time and I'll take example of yours. How many of you think that you are a lazy guy? Anybody who is lazy feels that I'm very lazy in your life? Anybody? Okay. Dhananjay or Saurabh also. Oh, me too. Many are there. Okay, good. ठीक है. So yes, so we'll take it. Dhananjay, example. ठीक. Because he has responded very early. ठीक है. So Dhananjay is lazy guy. Dhananjay, yes. Yes, he's a lazy guy. ठीक है. And who is a very gentleman, like, gentleman. Wife says, oh, bring milk. Okay. Bring this. Okay. Gentleman. Happy family. Chiru. Happy family. Oh, many of them, they're saying Chiru only. Okay, good. Chiru, please don't mind. We'll take your example. ठीक है ना? One consent. Chiru, is it fine? Chiranjeevi, is it fine? No problem. ठीक है. So Chiru is there and he's a gentleman, basically, I'll say. Gentleman. So, gentlemen, how they live their life. They don't want tension. They want happy life at all the time. So no much, nothing. Aram se. Life has to be cool way, cool manner. So let's take one example. And Chiru is there and staying with a wife. Married, right? Married, na? Huh?
Yes, Manish is married.
Okay. So married means ठीक है. So because if not married, then we'll give a girlfriend. What is there in our example? So we can give it. So gentlemen, no fighting, nothing. Aram se. So she's saying, I want to bring milk. So he will go to the market. Step number 1, he'll go to the market and bring the milk. Guys, please pay attention. I'm going to teach very tough concepts. Believe me. But how easy I'll teach, you'll think, oh, done. Bring milk. Okay. He will go to the market and he will bring it. Then second things she is saying, oh, please bring some, boil the milk. Boil the milk. So he will do that. Then step number 3, please bring some vegetable also. Bring some vegetable also. He will do that. Step number 4, cut the vegetable. Okay. Or put the vegetable in fridge. Or maybe cut only, we'll say. Cut vegetable for the making vegetables and all. Okay. Step number 5, the add milk or add sugar to boiling milk. Boiling milk. Add it. Okay. So he will do. Next, 6th. Again, 6 will come like add tea powder or maybe white, right? Coffee. Add coffee. And number 7, serve the tea. Simple. Simple, funny. Gentlemen know much nothing. Said, whatever order I will receive, I will follow and I will do in a serial manner. That's all. Whatever order I will receive, I will do it in serial manner. This is the normal gentleman job. One by one instructions he will be getting and one by one he will be keep on doing. Agreed or not? Anybody have a problem? With gentleman job is this only. Whatever they will get it, they will do it. Yes, guys? Yes or no? And due to this reason, their families are very happy. Due to this, always happy family. There is no much, no halla goli, nothing, silent story, always silent life. Yes, guys, happy? All right. On a contrast of the and guys, do you know that all programming language and all the tool, whatever you have learned in your life, they are your gentlemen. They are your gentlemen. Everything. If you write a is equal to 20, so it will initialize a is equal to 20. And if you write a is equal to 20 into 20, so it will do that. And c is equal to b minus a, so it will do that. No much, nothing. They all are gentlemen. What you write, they will follow you. And they will do in a sequential manner. If you have any problem, please let me know. All programming language, even your Informatica or Teradata also, they will follow the same. They are gentlemen. Now Dhananjaya is feeling lazy. Oh my God. Oh, he's going to do something with me. Gentleman job is this only, yes or no? Guys, anybody disagree with the gentleman job? This is what I feel. This is gentleman, right? This is the gentleman job, and all your programming skills are just like a gentleman. How you have written, how you have called, that will be get it done in the same serial manner. That's all. No additional nothing. Now we have another friend, Dhananjaya, and now, my dear friends, same instructions and same thing is there for him also. He's also got married. Got married, Dhananjaya, right? Yes or no? Dhananjaya got married? All right, ठीक है. Same instructions you are also getting. Same instructions you are also getting. But you are a lazy guy. Now you tell me, what is the status of a lazy guy? You tell me. You tell me, lazy guy, how they do their job in their life. Your life, you tell me. Your life, right? You tell me. Order it from Swiggy, that's all. ठीक है. My dear friends, lazy guy ka one cool feature is that they all lazy guy, the cool feature about the lazy guy, they will say, okay, yaar, I will do it. Okay, I will do it. Simple. All lazy guy you see, they will never say, no, I will not do it. Okay, we will. This will keyword is just like their protections. I will. Okay, I will. All lazy guy does it. Anybody who feel lazy, they will say, okay, I will do it. Okay. That's all. I will. My spark is the same. My spark, tea break. No, what is it? Okay. Okay. My spark is a lazy guy. So spark also say, okay, I will. Okay, I will. Something like that. Again, boil the milk. Okay, I will. Okay, I will. Okay, I will. Now you tell me, this lazy guy, when they will start working, this okay commitment, fake commitment he is trying to give, or commitment he is giving it. But this commitment, till which step is it okay? And when a step this commitment will not work? Steps I have written, right? Which step do you think? Sir, here okay will not work, please. Yes. Step number 7, this okay will not work, please. Step number 7 is an action time. If you will not give the tea, now fighting will start in family. This is an action time. I call it an action time. Step number 7 is an action time. Till step number 6 is fine. Okay. And then somebody boss will say, okay, if it is not done in this month, search for next job. Then, oh my God, see this? So this is the action time. So lazy guy also have some threshold, and then they will start working. So this is the action time. Step number 7 is the action time. Now, my Dhananjaya is a lazy guy, we have taken, but, and Spark is also is a lazy guy, we have accepted, but he's a very smart guy. Lazy and smart guy. My dear friends, my Dhananjaya is going to be very smart guy, Spark guy and smart guy. He's not like simple fake commitment. He's a very smart, very sharp-minded, very sharp-minded. So what he is going to do, he will be keep on sleeping until an actions comes in, and he start work only at action time. Guys, please listen. Very tough things I'm discussing. He starts working only at the action time. Starts working only point to be noted. Only at the action time. Till action, no problem. Okay. Now wife is saying, no, if you'll not bring the, you don't come to home. Then you see the speed. Are you getting my point? Yes. So if that is the action time, means if this will not happen today, then the fight. Don't come to home. So he's a very smart guy. And what he is going to do at the time, kindly mute some of you. Yeah. Okay. So at the action time, since he's a very smart guy, what he will do, he will prepare his own plan. Point to be noted, guys. What I'm saying, please listen. Very tough things I told you I'm going to discuss. He is going to prepare his own plan, means he will not execute what plan you have written. Here, what plan you have written, he will execute that, but he will plan his plan. Now, in his plan, he will just look for this action what is needed, and only such steps I will execute, and remaining I will not. I will not. Point to be noted. Now, I am going to prepare the plan. So now, action is for what? For a T. This is my action steps. This is my action time. Or I say it's going to be show time. This is my action time. Or I can say it's a show time. So whenever it's a show time comes in, Spark is going to prepare a plan. Now, for the plan, what is going to be getting done? So to do this step number 7, I have to go to step number 6. It's compulsory. Dependency are there. And then for 6, step number 5, dependency is there. I know that. Now for 5, fourth dependency I don't have, so I'll not go for fourth. And third also dependency I don't have, so I will not execute it. Step number 2 is dependent like this, okay. And step number 1 is dependent and like this. So now my plan will be prepared, and plan is going to be the step number 1, and then step number 2, and then step number 5 directly, and then step number 6, and that's all. Step number 7. This will be the plan. What plan he has prepared? This is the plan it's going to have. This is the plan we are going to have. Are you getting my point? So he will prepare his own plan, and this plan is going to be get it executed, not the plan what you have written in the proper manner. Guys, point to be noted. So this plan he is going to execute that rather than what you have written. So I am going to execute this plan, not the previous plan. Now, point to be noted, in this plan, our now plan is ready, and he will go and execute everything in the one shot. Point to be noted. He will do everything in one go. In one go. Point to be noted. So, in a one go, he will do everything together. Firstly, he'll bring the milk, boil the milk, add the sugar, add the coffee, and serve it. Everything will be done in a one go. Everything will be done in a one go. Now, don't you think, as far as the resource consumption is concerned, resource consumption is concerned, here Chiru is going to take lots of resources because he will go to the 2 times market and then so many resources he will consume. However, in case of Dhananjaya, we are going to take very less resources and he'll get only once in a market and he will execute only these steps. And what is unnecessary steps? I will not execute it because this is of no use. This is of no use in this case. Don't you think? Oh, very smart guy. So he will go to the only once to the market and he will finish his entire things what has to be done. So as far as the resource consumption is concerned, Dhananjaya will take very less resources, and since everything is going to be done in a one shot, it will be more faster and more quickly with a less resource consumption than the Chiru. Because Chiru will be consuming the resource because 2 times he has gone to the market, he has done so many things, and out of that only few things are needed. And on a contrast of that, Dhananjaya is getting the better deal. Yes or no? Do you guys agree with this one outer plan? Please confirm, then I'll give you a programming example also. We'll not stop with only tea, coffee. We'll take one programming examples. No, but being a developer, Dhananjaya, what I'm saying, being a developer, see, I don't know, I have written it. I have written it. I was not knowing it was not used or it was used. I don't know, but I have written it. I have written it. So it is going to waste your spaces in that sense. And that will create a problem. Let's take one real life example. Guys, have a look. I am saying A.
Manish, one question.
No, no, not now.
One
Not
question.
now. Is it not now? Is it okay if another 10 minutes after 10 minutes? Is it fine? Yeah, not now. Because we are in a halfway. We are in a halfway. That will create a trouble. A. Load a.csv. And it is of 1 terabyte. Have a look. I'm not taking question due to some reason because by taking T, we are not going to learn Spark. It is just to say the context. Here is the Spark. B. Now we'll take same example. Chiru and Dhananjay. I am saying split. A dot split based upon the space. C. B dot map for everything return that thing comma 1. D. Load b.csv 1 terabyte. I'm just assuming. E. B dot map, maybe or maybe split, maybe a comma separated. F. E dot map for all x or for all f return f comma f dot length. G. C dot filter the word spark. H. G dot count. That's all. I'm stopping only up to here, please. This is a simple plan I have written. This is the simple plan I have written. Now some of you will be thinking you have loaded, but you have not done some operations. I'll write it afterwards because I don't want to mesh it everything. So I will use it later on, not a problem. But this is the simple plan I have written. Please have a look and confirm. Please aram se take 1 minute time and have a water. All right. Had water? All right. Great. Plan is clear? Plan is clear, guys? Can you confirm? Plan is clear, everybody? Make it fast. Great. Now, plan is clear and everybody has the water. Please have a look. If it is the Cheru, you know, gentlemen, yes or no? And let's do a little more interesting. And each steps I'll take 1 hour ka gap. This is 9 a.m., 10 a.m., 11 a.m., 12 a.m., 12 p.m., sorry, 1 p.m., 2 p.m., 3 p.m., 4 p.m. This is the time frame I have written. It will not take 1 hour, but it's fine. Now, if it is a Cheru plan, gentleman guy, so gentleman will ask the data load into the memory. You know that. Load. So load, no doubt and no argument, please. You know, gentleman doesn't do argument. Whatever instructions you get it, you have to fulfill it. So load. So load means what? Memory load. So earlier data was there on a disk. Now I'm going to load it. So at 9 a.m., you need 1 terabyte of a memory. And the data will come and occupy your memory. It's fine. 10 a.m. you told, sir, you split it. So after splitting, data will be exploded. So now my data will be little higher than the 1 terabyte. What was our 1 terabyte? Something more will happen. Maybe 1.2 terabyte. Again, here the data will, for every data, I'm returning data comma 1. So it will become again more data. So it will become approximately 5 terabyte. And guys, till here, you are consuming 1.5 terabyte of space in your memory. Please don't forget that. That much you have occupied. That much you have occupied because you are in the progress of something. So you cannot keep anything on the disk. Don't forget that. By 12 p.m., you got instructions, please load one more data. So you need 1 terabyte again data. So 1 terabyte again memory, you need it. Again, you are trying to split it and filter it and this and all up to here. Again, you are going to get approximately 1 terabyte space. You are going to get it. And then ultimately you are going to count it. So here finally, maybe 200 MB data, I will get it. So as far as the resource consumption is concerned, from 9 a.m. till 4 p.m. approximately 2.3 terabyte memory you need it throughout the day. Please confirm. Throughout the day, approximately 3 terabyte memory, you are going to use it. And throughout the day, it's not about 4 o'clock. Throughout, from 9 to 4, approximately you need approximately that much. This is a sequential executions what we are going to do it. And this is what a simple plan, gentleman job. This is a gentleman job. Now, some of them, they have got a doubt. How come 1 terabyte? Because here you are saying for anything, return that thing comma 1. So earlier it was simple Manish, but now I'll get Manish comma 1. So data has become more, na baba. So data has become more. So means it's exploded. So that's what on an average I have taken for easy calculation. And like this. So data is getting more in these conditions. Guys, please have a look and please confirm. And you can ask any questions related to this plan. Related to this plan, if you have anything, you can. Yes, Kiran. Good. Now, this is the gentleman job and everything is going to be done like this. Now, coming back to Dhananjay. Dhananjay is there and he is a lazy guy. And as you know, this lazy guy doesn't start working and he say, okay, load. He will say, okay, split, okay, map, okay, load, okay, split, okay, okay, filter, okay. But count, no okay, please. Action time. Action time. Please confirm. Do you agree with my action plan? Do you agree with my action? This is the action time. Now, when is the action time? 4 o'clock. So, at 4 p.m., Dhananjaya, simple highlight, well, prepare his own plan. When? 4 o'clock. 4 o'clock. He will prepare his own plan. So, till 4 p.m., do you need anything? No, I don't need. Till 4 p.m., do you need anything? No. 4 p.m., he is going to prepare the plan. And in this plan, he will look for the dependency. Now, in the 4 p.m., he is going to prepare the plan. Okay. So G dot count. Okay. Go to the Z. C dot filter. Go to the C. And B dot. Okay. Go to the B. A dot. Okay. Great. I have a plan ready. What to be done? A, then B, then C, and then G, and then the H. This is the plan I'm going to execute. So Dhananjaya will make this plan at 4 p.m. Firstly, planning will be done. What he is going to do in his life. Not in his life, his program life. So 4 p.m. this plan will be prepared, and this plan is having dependency, and we call it as a DAG. We call it as a DAG. What is DAG? Directed acyclic graph. Directed acyclic graph. Directed means direction. Acyclic graph. Direction involved because dependency. This arrow means who is dependent on whom. So B is dependent on A, C is dependent on B, like this. And acyclic, assume that somewhere some developer have written like this, which was resulting with the same, it will not execute, or maybe like this. So anywhere, if somewhere cycles are getting formed, Spark will just create a reference. Actually, calculation, it will not do that. Whenever it is needed, it will just supply the same data. It will just supply the same data. So that's what it's a prepare a cyclic graph. So somewhere, if the new developer has written somewhere cycles, Spark itself, it will eliminate it. Spark will not prepare it. So DAG will be prepared, and this DAG are going to hit your hardware. So this DAG will be executed. This DAG will be shared with all JVMs, or I can say executors, and then execution will start. And this will be getting executed, number one. So now 4 p.m. I'm going to get some resources. So at 4 p.m. I am going to load my data. ठीक है, I will load a data, no problem. So till 4 p.m. so you don't need anything, that's for sure. And that is a cool feature Spark does that have. Even in 4 p.m., what I was saying, a load, again, loading. So 1 terabyte, are you going to load in a one machines? No, not one machine, sir. Again, parallel processing, 1, 2, 3, block by block, you know that. Now I'll not draw so many blocks, 4 blocks. It will be get loaded in a 4 executors, and this will be my executor number 1, executor number 2, executor number 3, and executor number 4. And this 4 executor will load the 4 blocks, and they are running in a different machines or whatever, you know that. And this executor will load it, split it, map it, filter, and final answers. And again, same for this. So here parallel processing is happening. These executors are going to do the parallel processing, but everybody is going to do the same steps. What is the steps? Load. B means split. C means not C. Map. And G means filter. And H means count. So what I'm going to do, all this locally, everything, one block I will load it, a small amount of data, and everything I'll do in a one go. It will not do step by step. Everything, whatever you have loaded, maybe in a block also, maybe I have loaded only 10 lines of a code in the memory. So that 10 lines will be loaded, splitted, mapped, filtered, and count. Final answer. That's all. And finally, this all count is going to be get it accumulated here. And it will be get it on count plus count plus count plus count plus count plus count. And final answer will be produced at last. So till 4 p.m. I don't need, number one, till 4 p.m. I don't need any resources. And at 4 p.m. also, I don't need 2 terabyte or 3 terabyte, number one. This though I don't need it at all. And even in this also, 1 terabyte, I don't need altogether. Maybe lesser amount, some 10 blocks only I will load it, and that 10 blocks only I will execute. So I don't need it 1 terabyte of a block at that time also. So only 10 blocks will be loaded, and that 10 blocks finished, then another 10 blocks, then another 10 blocks, then another 10 blocks, then another 10 blocks aligned like that. I can finish all 1000 blocks of executions with the 10 executor itself. So this is the beauty of your DAG, Spark, lazy evaluations, lazy guy, but smart guy. Now I have done it. Now, as far as a parallel processing are concerned, you buddies know the parallel processing is happening here. In every steps, there is a parallel processing across the block. It's not about A and B will be done parallelly, like load and split parallelly. Sir, how? It's a relay, right? It's a dependent. So that will be done like this way. So this is the how it is going to be get it done. Now, some of you may be thinking, but sir, I am a good developer. Why you have written like this? I have written something, I have kept something in my mind. At 5 p.m., I have written some code and I told E dot or F G H I, and then I'm saying F dot count. I will say this because I have written some data. So I'm not a complete, I have written with some sense, right? Correct. No problem. I have a no problem. Now, again, 5 p.m. it's another action. So again, new action plan will be created. New action plan will be created. 5 p.m. So what is the action plan I'm making for this? What is needed for I? F. So I'll go to the F, then E, then D. Okay. Now this is the new plan. So there is a new plan D, then E, D, E, and then F, and then I. That's all. And this is also going to be do the similar process. That is no differences. Similar process. And now, point to be noted, the earlier graph and this graph, both is going to be a part of the DAG. This is the another DAG, basically. And they both are independent. I repeat, both are independent. Since there is an independent, they can start in parallel. They can start in parallel, provided resources you have. They can start in parallel. So this graph, and this graph, they can start in parallel. There is no concern about the parallel processing of this. So it can have a two level of parallelism. Number one, this part of the DAG and this part of the DAG can start in parallel. And here within this DAG also, here parallelism can be possible. And here also parallelism can be possible. Now, this is how we are going to do it. So similarly, you can say something more. And below, I have written K is equal to join K, and I have written I and join with maybe H. ठीक है, no problem. So now dependency steps have came. See here. So how my DAG is increasing? See, I will tell you. Now this is now two DAGs was there. Both can run in parallel, and this count will come here, and here there is going to be a join operations. Fine. The join is dependent on the both of the above. So until this both finishes, join will not start. The join will wait until the above DAG is getting finished, because that is dependent process. That is dependent process. And if it is a dependent process, it is going to create a dependency. You have to wait until the above both the DAGs gets prepared. Until this all block processing finishes, you cannot start trigger your join operations. You cannot join this join operations. So join will be dependent. So it has to wait until the above both has been finished their executions. I hope you have got the point about lazy guy, about the DAG, about the dependencies and all like that. Now I'm giving time for you. Firstly, analyze and then ask your questions. Over to you. Take some time, try to look into it, and then we will take your questions. No problem, Saurav, no problem. Apart from that, anything else, please? Yes, guys. Any questions, please? Earlier, some of you asked the question I have restricted. Kindly ask now. Kindly ask now. I was in a middle, that's why I have not taken that. Now you can ask your questions, please.
Manish?
Mm-hmm.
Yeah. In this like DAG, you have given like we have the parallel processing like E1, E2, E3, E4, and there you said like it won't be using 1 terabyte at a time. It is like as we
Yes.
have different blocks, 10, it will be divided. But as it is a parallel processing, so in total it will be using total 1 TB, right? So how come there we have a saving part? I mean, less consumption.
Yes. Not about the less consumption. I am saying if you got that many executors that can load 1 terabyte, it's well and good. It's just like you have a 20 members and you have a car with a 4-seater. That's all. So if you have a 1 car, so 4 attempts you make it. Or if you have a 5 cars, all good. In a 1 attempt, you can do it. So I'm saying 1 terabyte, not necessary I'm going to load into the memory. How many executors I got it, and every executor, how many RAM I have available, I will try to accommodate with that.
Okay. Yeah, got it now.
It's just like a car, and that example you think that will be better way. Please ask your questions. So this is what about the DAG and all. Over to you. Take some time and yes, friends, anyone else have any questions, please? Anyone else have any questions, please? All right, try to see here what example I'm trying to say. Don't you think it will produce the same answers what X is talking about? It's cyclic. So whenever you are going to prepare a DAG, Spark sees it. And in some cases, maybe developer has written some code that is going to prepare one cycle. Like this steps, and after this is going to do maybe this steps. It is returning to the previous steps. And this is also happening. Have you seen some programs like that? That this steps is resulting with the seventh one or something like cyclic? There are multiple graphs are there that returns to the same cycle. Multiple examples are there that returns to the same cycle. Have you seen any kind of such incidents in your life? Yes, guys? Anybody? No? Anybody, have you seen such kind of a scenario while executing the program, it is returning to the same one? Maybe possible, right? Maybe possible, not getting. Yes. Yes, I will. What I am saying, I have some step number 1, then I'm going to step number 2, then I'm going to the step number 3, and step number 3, somehow it is resulting to the any one of the previous steps that already I have. That is resulting with the same steps that I have. Step number 3, execution, results with the previous steps. That is called step number 1. Have you seen some kind of equations like this? Resultant are going to be the same. You have seen multiple cases. But if you have normal execution, even Informatica or Java or whatever language you have, that will execute the step number 1, that will execute the step number 2, that will execute the step number 3. That will do it without fail. I repeat, that will do it without fail. But Spark will not do this. Spark will not do this evaluations. It will say 3 and 1 both are the same. So wherever 3 is there, it will initialize with a 1 without calculation. 3 means 1. That's all. No need to evaluate 2 and then evaluate 3. 3 means 1. That's all. By seeing the graph only, because DAG will be prepared first. And then the execution is going to happen. Then the execution is going to happen. So it will not do the execution. It will just replace it. 3 is equal to 1. 3 is equal to 1. It will do that. Sort of. Now one real life example I'll give it. Maybe you are dealing with the cart example, or maybe a friends list on the Facebook. Friends list on the Facebook. Now, don't you think my friend, I am a friend of somebody and somebody friend is somebody, and that friend also I am a friend of that body. You have seen such kind of a scenario. So again, I am coming in that. So again, Facebook iteration, does it do for myself one more time? No. Mine execution already done it. I'll take again repeating example. I have a Facebook, and Facebook is running one graphical analysis for Manish and how many friends I can suggest to him. So Manish's friend is maybe 3 body, A, B, and C. And then B friend I am looking, it's going to be D, E, and C. And again, if C friend I am seeing, I'm getting Manish. So will I reiterate for a Manish? It's just a cycle. So don't do that. Wherever Manish comes in, put his friend all together. So that kind of initializations. So if you'll go for a normal processing, this graph won't be eliminated. However, Spark say, no, I know this answer of this. I will not take any resources here. I repeat, I will not take any resources here. Directly, wherever 3 is coming, I will put 1 without any effort. 3 means 1. 3 means 1. That's all. Sort of. My dear friends, please confirm. I hope now you got the idea about what is Spark, and And now to at least nobody is there who will say, I'm not convinced with a Spark. My dear friends, anybody now are you saying, I'm not impressed? All right. All right. Now, try to see here. Here, whatever we have written here, A is equal to load, B is equal to, I have written C is equal to, D is equal to F. You have written something. Yeah, just 2 minutes. Okay, take a break then. ठीक है. We'll take a break then. We'll go for a tea break, guys. 15 minutes maximum, 15 to Chiranjeevi, can you come again with the join operation in lazy operation? We will take Chiranjeevi slowly, don't worry. Join we will be discussing maybe day 3. Don't worry, I'll be discussing. Lazy, so now only we have started with the laziness, right? I will show you the practically, don't worry. Yes. Some practical example of laziness I will show you. We will take a break here for a lunch break. Sorry. Okay. We'll go for a tea break now. And post tea break, I'm going to discuss about RDDs and we'll start the practical now. RDD. So post lunch, post break, we are going to discuss about the RDD and we'll start with the practical. Thank you. Have a break. Maximum 15 to 20 minutes, not more than that. It's evening time, so I know you need some snacks or something. So we'll take something. Yes. All right. Baby Chiranjeevi, after the break, we'll discuss. Yes, I will discuss. No problem. All right. Take a break, guys. Thank you. Thank you so much. Hello, friends. Have you returned back? All right. All right. Now, you know that here so many steps I have written. So many steps I have written. Now I have written A, B, C, D. In programming terms, what do you call A is what? In programming terminologies, what is this A, B, C, D and all? That's all. It's a variable. Very good. It's a variables. That's all. Nothing more than that. In Spark terminologies, we call it as a RDD. We call it as a RDD. What is that RDD? It's called it is a resilient full form. Forget it. We'll discuss tomorrow full form. It's RDD. So A is a RDD, B is a RDD, C is a RDD, D. Everything is going to be an RDD. Everything is going to be a RDD. That's all. Full form tomorrow we will discuss because there are some concepts are there involved and we are going to do that. Now, point to be noted, this all RDDs are immutable. It's going to be immutable. Immutable means that can't be changed. It can't be changed. All RDDs are going to be immutable. It means it can't be changed. And in Spark terminology, it has a no cost because until I call an action, that has a no problem. So if you don't need D, no problem, leave it because it is not consuming your resources. It is not, you create a new one. That's all, silly things. I repeat, you create a new one. That's so simple. That's so simple. Create a new one. If you don't need something, you just leave it. Because just creation of the variables, it doesn't make any differences. It doesn't create any differences. So it's just immutable. Just immutable. So create a new one. Simple. Create a new one. So that is going to be just like a variables, and normal variables takes a space. But here it doesn't take a space until an action is called on it. Until an action is called on it. And it is going to be immutable. Immutable. So that is how an RDD is talking about, or just a full form. We will say it, half part I will say it, resilient, RDD. So this one was a secret behind the success of your Spark. That is called resilient distributed data sets. Now, don't get confused with this. What you know, that is true. It is basically a variables. And it's a special kind of a variable because it doesn't contain any memory until an action is called. And it's a distributed, point to be noted. It's a variable, but a special variety. It's a distributed and data sets, but it doesn't contain a data until an action is being called. I repeat, it doesn't contain any data until an action is called. And what is the meaning of resilient? I'll discuss it tomorrow. Because today, lots of theoretical discussions already you have it. So this is how we are going to do it. Now, so this is the success behind the scene. It's RDD. Please confirm if you are agree and everything is happy. If you have any questions, please ask. Else we will go ahead and we'll start with some practicals. So guys, as morning I told, only today it's going to be theories. Apart from today, till day 4, all practicals. And again, day 5, morning hours, 2 hours theory, and again, remaining practicals. So today I have given some theoretical background because that was needed. I hope you buddies have built up your concepts. Yes, guys, can you confirm everyone? Over to you. Can you confirm everyone? It's a lab time now. Everybody got the lab credentials? Hello, friends. Everybody, have you got your lab credentials? Anyone who didn't get it, please let me know. I hope you have the console where you can just go and start this. Morning hours, they have already given it to you. Kindly log in. Kindly log in. Yes, if you have something in your machines, then also it's fine. That is not a problem. Some downloads we are going to do. So if that all options is available, you can do in your system as well. How many of you want to practice in your system? Okay, many of them. Okay, ठीक है. So I have to just discuss about something. All right. So what do you do? Not okay. We'll see. To do our practicals, we are going to use a IDE. You know, our course deals with the Java. So we are going to discuss Spark with Java, as you know that, and you buddy already got trained with the Java, right? Yes or no? You buddies got trained with the Java. Everybody agreed with me? Huh. Because that is a Java is prerequisite for this training. I repeat, this is a prerequisite, and that training already has happened for you for the Java. And that was the already I got informations from your L&D department that you already have a Java developers. All are Java developers, or they got a trained on a Java, and you are here in our training. Now, you know, for running a Java, we are going to use a IDE, Integrated Development Environment, and there are two major popular. One is called IntelliJ, and other one is called Eclipse. You tell me which one are you like it. Which one do you like it? We are going to use this only. IntelliJ, right? All right. Hello. No, some of them they are saying no audio.
I can hear you, Manish.
Yeah.
Now I am able to hear you, Manish.
All right. So first of all, let me teach with the IntelliJ idea. And since today time is less, so I will try to show in the cloud VM, and the same you are going to do by your own in your system as well. Here, something already I have set it up. So I will guide you how to do that. In IntelliJ, do you know how to prepare, how to create a Maven project? Do you know that? How to create a Maven project? How to prepare a Maven project? No, many of them, they don't know. All right. So actually last training, there was some people that was getting issues. So I have set it up and I have given ready-made things to you, but actually you should learn it. Not a problem. What you are going to do, you are going to do, you have to open IntelliJ IDEA. Aram se you listen me first. Or Eclipse, both are the same process. And here you have to write.
But I think before that, Manish, a couple of folks do not have their user ID. So do we know? I think does everybody have their own user ID?
They don't have it. I will.
Yeah, a couple of folks. I think I saw the chat.
Okay, yeah. They don't have it. That is the problem. Okay, 1 minute. Those who have the user ID, can you message your user ID in chat window? Hello, friends, because I was not there morning hours. So I was having, yes. Can you paste me? I will make a note of it. 1 minute. Let me take pen and paper. Yes, I'll take pen and paper and then I'll give you the other user ID for others. Yeah, it will take some time. I'm making a note of it. No. Just 2-3 minutes, that's all. I am making a mark. 1, 2, 9, 10, 12. Please message your user ID. I'm waiting. No, how many they got the user ID? I'm asking that. How many of they got the user ID? I'm asking for them. Chiranjeevi 22 to 23. No, user ID. No, don't say I have or I don't have. Just message your user ID. I'm making a mark, then I can allocate some other machines to other buddy. 7. No, already 7 you have messaged, then it's fine. 22, 23. 22 already is available. Yes. Yes, guys, anybody else who have not messaged their user ID? 7 already you have it. All right. What is left behind? All right. Hello, friends. I am going to speak some of the names. If it belongs to you, please let me know. User 8, does it belongs to anybody? User 8, does it belongs to anybody? Next, user 15, does it belongs to anybody? User 15, does it belongs to anybody? User 18, does it belongs to anybody? I repeat, 18, user 18. Next, user 24, does it belongs to anybody? User 24, does it belongs to anybody? User 25, does it belongs to anybody? User 25, does it belongs to anyone? All right. This many machines I have as a free. Now, how many of you don't have the user ID? Please message one by one. How many of you don't have the user ID for a login? Please message 1 minute. Ayushi. Ayushi, you are going to use 8. Aha. Sastri belongs to me. Oh, Sastri, I have asked, not 25. Okay. Take care. 1 minute. Ayushi, you are going to use 8 number. Ayushi, 8. User 8. All right. I'm canceling it. Next, anyone who don't have the user ID? Hello, friends. Anyone who don't have the user ID? Fajuddin, Spark 8 IUC. Yes, yes. Yes. So, login page, you already have it. URL, I am sharing it to you, to everyone. URL, I am sharing to everybody. And thereafter, user ID will be for IUC. Its user ID will be like this. And user ID and password is going to be this. All right. User ID and password. All the 3 things I have given. Ayushi, kindly use it. Anyone else who don't have the user ID? Kindly confirm, guys. Hello, everyone. Earlier, many of them, they told they don't have. Now nobody is responding. Yes. Yeah. User 08. Yes, that's true. User 08. That's true. Ayushi, kindly put 08, not only 8. It's a 08. Are you able to log into the VM as I am showing in my screen? As I am able to showing my screen, are you able to do? Everybody, are you able to do this? Please confirm.
Yes, Manish. Yes.
Great. Now, I was discussing how can I create a Maven project. Now, you know, Maven project is what? It's just a project with the dependencies. There are so many projects are there which is having dependency. As for example, your IntelliJ doesn't know what is Spark, or this VM doesn't know what is Spark or what is Kafka. So there are some additional executable jar files are there that I can add to my program, and then that can invoke the functionality. And for that, external library management is going to use a jar file. And for that, there are 2 variety of projects that can be done. One is called Maven, or other one is called SBT. or other one is called as a Gradle. All are the same only. All does the similar activities. All does the similar activities. They just manage package management basically. All does the similar activities. So in my class now, I'll be teaching with a Maven. Later, somebody have asked, can you discuss about the SBT also? Of course. But all are the same. Now I am repeating again. Can you mute yourself, please? Hello, mute your audio, and whenever is needed, you can unmute. Yes, great. So we are going to create a Maven project. How to create a Maven project? Open your Eclipse, and while opening, there will be options called New Project, and in that I have to choose Maven. Open New Project, and I have to choose Maven. So if I just open it here, in this, I already have set up. So it will start with this Spark training. So if you buddies wants to, see it's showing update, okay, update it, something like that. Already I have set up one demo programs for you all. So if you want to do it, it's fine, that can be done. You want to do? All right. So if you want to do, that is not a problem. I will teach you how to do it. What you are going to do, my dear friends, before you go here, open the Eclipse, everybody. I don't want any problem. So open the Eclipse. Open the Eclipse or IntelliJ, whatever of your choice, please open. Please open. Please follow, because it's not in classroom environment. So sometime it creates problem. So I want everybody to be on a same page. That will help. Have you opened your IntelliJ IDEA? All right. Or Eclipse. Both the guys, though, who are following Eclipse, then also no problem. Same steps you follow, you will get your solutions. Now here, there is something called file available called pom.xml. In my screen, please have a look. Pom.xml you have. Please do a double click. Pom.xml. I'm just doing a double click, pom.xml. And please have a look. Everything is in there in a green color. All good. All good. Everything is there in a green color. Everything is fine. There is no problem. So you can do one thing. You can do one thing. As an easy setup, I am just doing copy everything. Because if tomorrow, if you face some issues, you should not. And here, open a text pad and you store it here. I'm just storing it, that's all. Just for backup purpose. Just for backup purpose. I have copied that content of pom.xml and I have kept in this file as a easy setup. Keep it with you. I have just copied everything from the IntelliJ. So everybody.
So, Manish, I think it's just showing IntelliJ, but there are no actions being done like copy or something.
No action here. IntelliJ you have opened, right?
Yeah, I think now it started moving.
Yeah. Pom.xml, please do a double click on pom.xml and do a Control A, Control C. Copy. And then in a notepad, you paste it.
I think we are not able to do in the same test book. Got it.
Guys, anybody who face any issues, let me know then and there itself, because it creates problem in virtual training. Lab session will be really hectic. If you don't get it now only, please let me know. Don't say after half an hour. It creates a big problem. I have kept for safer purpose here. I have kept it for safer purpose here. That's all. Now I'm starting my IntelliJ. All okay? Now, those who are working with IntelliJ, you have to firstly follow IntelliJ guy, and then I will show you in Eclipse also. Wait a second. Let me start with Eclipse also. It's there. Or anyway, both are the same, only you start one, I'll teach it, then maybe after this second one we will do. Then the after one, second one we will do. Please. Guys, I'm moving further. Click on File, New, Project. What I'm saying, just do a single click. That's all. Don't do here and there. File, New, Project. I'm waiting. File, New, Project. Though who likes IntelliJ or Eclipse, both of you please do. Same steps you have to repeat for Eclipse also. File, New, Project. I am clicking now. It has opened something like this. Please have a look. Make sure that you have clicked on Maven. Click on Maven, and right hand side you see project SDK. It is showing as a 1.8. Make sure that you have selected Maven in left hand side, and right side it is showing project SDK Java 1.8. Please confirm. Everybody please confirm. And no fast, slowly, give me some time. Last training, you don't believe me. Even I was in a trouble. You know what? This setup only 2 days we did. I mean, second day also, one buddy ka setup, I did it in second day, approximately lunch break. Starting, they told, no, I did it. And then now feel free. If you are not getting, I'm there with you. It's a promise. I'll not do anything. Aram se let me know. I will help. Maven 1.8. Click on next. Everybody click on next.
And Manish, if it is already existing, we don't have to do anything, right? Or do we have to?
No need to do it. Yes, already I have created, but they want to learn it how to do.
Okay, got it. Thank you.
Already I have created for you Spark training, but they want no, I want to learn it. So that's what I'm teaching. Click on new, guys, and next. Click on next. It will ask for the name of the project, what name you want. So I'll write JPMC Spark training. You write any name, that is not a problem. JPMC Spark training. This will be name of the project, what you are going to create. Please click on finish. Click on finish. The moment you click on finish, it will ask, do you want to open in this window or new window? You choose whatever you want. Maybe this window, it's fine. This window. So it will overwrite and it will blank page will come here. Just wait for a second. It will open like this. I have clicked on this window. I hope everybody got the same page. Now, to run the Spark project, I repeat, to write a Spark project, I'll be writing some keywords that will be Spark keywords. But this IntelliJ will say, I don't know Spark. So what I'm going to do, I am going to add Spark library functions. I am going to add Spark library functions as a dependency. as a dependency. So to do so, what you are going to do here, project is there, I will hit enter and I will write dependencies, something like that. You can write dependencies and close the tag. That's all. And all such dependency I will paste in between here. Either 1, 2 or 100, all dependencies I will paste it here. I have typed dependencies. Please have a look. Please have a look. I have typed dependencies, and that dependencies are above the project tag, guys, not below tag. Above the project tag, I have a dependencies. All right. Now, next things what we are going to do. First dependency, what I'm going to add. First dependency, what I'm going to add, that will be Spark Core. I repeat, first one, I am going to add Spark Core dependency. So it's a Maven project. So I will Google it, simple. I will go on my Google. And I'll say Spark Core Maven. Simple, I will Google it. Spark Core Maven. And if I open, it will open all this project. Spark Core Maven. Go to any version, it's fine. Come here. And all Spark versions available. 2.4, 2.3, all versions are available. Which version you like, it's fine. Maybe 2.4.4 I like. So I click on 2.4.4. So I am clicking. And the moment I click, it will open Spark Core project. And here below it is showing the dependency. Please have a look. Maven, Gradle, SBT, IV, Grapple, all are available. You know, SBT, I have to copy this. Maven, I have to copy this. Is it clear? Can you confirm? Is it clear? Now this is what we are going to do. So we have to copy it. So to make it simple, because many people will be Googling different. So we will not copy from here. Already the same thing I have just now given it to you on your desktop, right? Please open the Maven dependency, what is available in desktop. In a text document, we have stored it. So to make a same version, I am just going with this one, so that somebody will choose 2.4.2 and 1.4.2. It will create a problem, and I don't want that. Oh, it's gone, huh? So
I think you gave 2.1.2, I think, right? 2.1.2.
No, don't copy from the Google. I repeat.
I'm just checking I'm taking your form XML only. In that, if you see the Spark Core, it is 2.12, I think.
2.4.3 here. Guys, please have a look here. The first one it's showing, I have downloaded here 2.4.3. Any version is no problem. I repeat, any version is no problem. But what happens? Somebody in the class, they will do something different core for a Spark Core, some different for a SQL, and some other for this one. And that will be mismatch. And I don't want that. And for that reason, I taught you how to do, but we will copy from here. But if you look on a Maven, same content. Please have a look. Same content. Same content. But you copy from here. Copy, and paste into the dependency here. Copy and paste. Paste. Simple. The moment you paste it, it will ask for a reload here. Have a look. Maven reload. Yes, reload. So it will start downloading all your Spark library, and then it will be green color, everything means blue, yellow, green. No red color will come. So now we are ready to run our Spark core. Kindly mute your audio. Yes. Guys, please keep on following. Slowly you will be learning how to do that. So this is the Spark core, and I'm ready to run RDD projects without any problem. I can run RDD. Please write it and reload the Maven. Yes, red line, you got it. Don't worry. Wait for a second. It will download. It will download here. M will be there, right? Coming. Reload your Maven project. You know how to reload, right? If you are getting red color, don't know. Okay, Control O, I hope. Control O. It will reload. Or just for a here, 1 second. Though who are getting a problem here, M kind of a thing symbol is coming with a globe at this location. Though, yes. Import change. It make it auto import. Yes, click on there, it will import it. And while importing, the below options will come import, make it auto import, enable auto import. So you click on automatically, it will be keep on doing it. Please do so. And guys, don't copy from the Google. I have taught you how to copy, that's all. Because 30 members are there and everybody will copy different form, and some compatibility issues will come and they will say, sir, I'm not getting. I don't want that. So we will make it a common platform. Everything become green color, yellow color, and cool, right? There is no red color. If red color is coming, reload it. It will take some time, download, and that's all. Sudhakar, you got it right? Red color gone? Hello, Sudhakar.
Hello. No, Manish.
It's downloading?
Yeah, it's downloading. I'm checking.
Okay, no problem. Then wait for some time. No worry, leave it. Others, now we are ready for this one. Now, the next dependency, what we are going to add up. I repeat, next dependency, what we are going to add up, that is for Spark SQL. What we will be doing a lab for a day 3. I repeat, day 3, we'll be doing a lab for Spark SQL. And for that also, I have to add the dependency. I repeat, for that also, I have to add the dependency. And what you have to do, again, go on a Google and just look for Spark SQL Maven. Spark SQL Maven. I'll click on and I'll go on the same page, Spark SQL Maven, and see the same way all the dependency will open. Same thing, Spark SQL 2.12 and all. Now, again, yeah, from here I'll copy paste, but as a safer side, we will not copy from here. Already we have available in the text document for the Spark SQL. See here, Spark SQL available. So please make a copy from here. Spark SQL. Do a copy and make a paste here. Now, those who are getting red color and they don't know how to reload the Maven, please have a look in my screen. The moment I will paste it, here, have a look. There is a M button coming in my screen. This M, it means nothing but a red reload. Click on here, it will reload. This M button, it will reload it. It will re-download your Spark SQL. Spark SQL. Now you may think, sir, here 2.4.3 is there, 2.4.7 is there. So it is compatible, that's why. But sometime it creates a problem. But it is Spark, that much problem, it is not available, so it's fine. But it's always advisable that you should put the similar one. But it's fine, it's working. Already I have tested. So it's working absolutely correct. So you can make it 2.4. anything. So please do so and reload it. I am reloading. See here, Control Shift O is a shortcut key for it. Control Shift O, or simple click it. The moment you click here below it is started downloading it. All right, all red color gone. Now, once this two dependency I have added, there are two more dependency I have to add. The third dependency is talking about the Java unit. I repeat, third one is talking about the Java unit, J unit. So it's for J unit, and the same thing is going to be, some questions are coming. Chandan, 2.4.7 is not available in our JPMC repo. So let's, yes, 2.4.3 only, it's fine. Make it 4.3, it's fine. That is all. Make it 2.4.3, no worries. 3 also, if you make it's fine. See, now red color is coming. It will download it. It means it is asking reload it. So it will download all the jars for this. See, it's showing red color. Red color will goes away in some time. See, below it is showing downloading. And once download everything done, see, color has been changed. Color has been changed. So 2.4.3 and I have added. Thereafter, we are going to add two more dependency. One for JUnit for a Java, and number two for log for J. You know log for J for what? Anyone? Log for J, what it does? It just controls all the log file gets generated during the program execution. And believe me, during the Spark programs, there are huge amount of logs gets generated. So to control that, I am going to put log for J. And number 3, to deal with the XML data, you have to download for Databricks package for XML, and for streaming that will be used in the last day. We are going to use Spark streaming. Still Kafka is not there. So Kafka we will add on a day 5. Kafka we will add on a day 5. And you have learned how to download the Maven and look for this dependency. You know this. So now I will just do a copy paste and I'll save some time. I will just copy and come here and paste, and that's all. I will reload it so that it will scan and your job finished. Guys, please do the copy paste. It will be easy, but I'm not doing very rocket science. If you just Google it, I have taught you how to Google, right? For this also log4j Maven. If you Google, you will get it. I will show it to you. Log4j Maven. Log4j Maven. You will get it. See, log4j Maven. So anything, whatever you look for in Google, you will get it. So don't worry about this. This is how you are going to prepare. My dependencies are all done. Till day 4, I can manage with this. I repeat, till day 4, I can manage with this. Day 5, Kafka is not available. So we will add on a day 5. Let it be. We will add it for a day 5. I'm waiting for your kind response.
What is Databricks for? You said?
Manish, quick question on the plugins that we have, right? So, it's complaining about plugins are not available. So,
Which plugin?
on the top, like it's not there. I just opened the sample that you have shared.
Apache Maven plugin,
Yeah.
what is like, yeah. And the other one also I got like two plugins, whatever there's at line 13 and 14. Maybe same
So
one.
can we remove that from the setup that you have shared? So just wanted to know.
No, what you are saying, line number 13 in my screen?
No.
No, the one that we have in your sample setup that you gave, right, on the server.
Uh-huh.
So if I don't change anything, I see plugins, yeah, on the top, yeah.
No, this will be created
this-
automatically. This will be done. Don't worry about that.
Okay.
So we have to remove it. Like what we have done is at the end, I have copied everything. So I need to remove that, right?
Yes, yes. So you do one thing, remove everything and copy paste everything again. But again, only dependency you add, no? Because the name again here, it's a Spark training. Project name is Spark training. So you have to change that.
And,
1 minute.
And I did not change anything. So, but still it is complaining about these plugins. So
No
just wanted
problem.
to know.
I will look into your screen then. Please share your screen.
See my, right? So this is like, I've not changed anything, whatever was existing in the sample, the dependencies and all, it's still there. But when I am opening this form.xml, it's complaining about these two things in red, saying plugin not found.
Okay. So shall we create one more time now?
Sure.
Yeah. Click on file. Anybody else who are getting issues, please, you can refer it. Click on file, new project. Maven, yes, next. 1 minute, just a second. Hiya, next. Now you can write some name, maybe Gaf, whatever name you want. This will be a project name. Means everything will go inside this. This will be a folder will be created. Not test.
Right.
1 minute. It will be entire 5 days. Your files will be stored in this itself. So maybe Ankur training. Okay. Finish. Finish. This window. All right. Below the project, click on once. Click above the project. Write dependencies. Write dependencies. Select it. Already it's coming now. Select that. Dependencies. First one. First one. First one. Dependencies. Yes. First one. Yes. Enter. Leave some 5-6 spaces. Enter something. Yes. Now all the Maven, whatever we are going to copy paste here only. So now copy that file, open the text. Now we'll start copying from this one, Spark core. Spark core, yeah, from here, yes. Copy, everything all in a once you copy. Scroll down, copy, next also, all together dependency. Copy. You know how to create it. Maybe, yes, paste. All right, wait for a second. Now reload the project. Reload the project. M is there, click on the M. Here, on the screen. Where your M is there, Control O also, you can Control Shift O.
Yeah. Yep. Yeah.
Or M is showing, yes, click on. That's all. Just wait for a second. It will take some time. In your machine, it will not take time because I already have downloaded once. So that's all, job done. Scroll up and see, is there any red color?
Nope, I think those plugins are not required, I think. Then. Yep. It's a green one. Yeah. No
Anybody
problem.
else? Yes, that's all, solved. No problem.
Thank you.
Yeah, welcome. Yes, friends, anybody else have anything? Please let me
For
know
me,
now only.
For me, it's getting one red color.
Show the screen, please.
Yeah. Let me know if you are able to see me. Are you able to see my screen, Manish?
Yes.
Yeah, here I am getting. This is the warning that I am getting.
Something it got changed.
Yeah, instead of copying only the dependencies, I have copied the complete POM XML, which I have copied earlier to the notepad.
Who will check this? Who create a new project? Who will check this?
Yeah, this is the entire thing. Earlier, while I am
Sometime-
copying, just I have cut this line. So this line was not there. So and again, when I do the POM XML, from there I copied this and I again pasted.
What happens? No, sometimes you are copying from different editors. Some symbols gets changed. UTF gets changed. So
okay. And here, what are the errors that we got? Model version child tag cannot resolve this exercise. All this can be.
HTTP is not found. Yeah, something it's wrong. It's gone. Do one more time, then it's better.
Yeah, 1 second. I'm doing it. Just
yeah, I'll wait. No problem. Project.
Java 1.8.
That's wait. Yes. Next. Write a name. Your name Sudhakar Training or something, JPMC, whatever. It will be created a folder, and inside your folder, everything till day 5 it will be stored. Yes.
Finish, right? Idea project.
That's all. This window.
So this is the and here.
Enter. Write dependencies with a tag. If you tag, select the first one. Enter. That's all. And only copy the dependencies, not the remaining things. Remaining things is just a.
From where should I copy?
Scroll down. Dependencies. See here also. Up. Dependencies will be there, right? Starting dependencies here. Now the top line, what you have in the dependencies. So don't copy the dependencies. That line already you have written, typed, right? So what we are doing, are you getting the point? Because tomorrow you need something extra, so you Google it. Maven and all. Maven, name of the project, and paste. So it will give you the Maven repository. 1 minute. While copy paste, confirm it. Is it correct, no?
Yes.
Yeah, double confirmation. Yeah. Now paste it. Yes. Scroll up a little bit. We'll see. Is it everything fine? Dependencies. Yeah, everything is fine. Reload the Maven. Yes. That's all. It's downloading. It will take another 1 or 2 minutes and it will be done.
Okay. From dependency to dependency, from this line, this is the repository tag from where it downloads, right? Spark streaming.
Yes, yes, yes.
And this is the access D related to that. Okay. Fine. I think now it got green color.
Yes.
No problem. Thanks, Manish.
Thank you so much.
Yeah, thanks.
Anybody else have any problem? Please let me know today itself. Because I don't want till tomorrow the same. Maven setup till tomorrow I don't want, guys. All right. So everybody got it. And you have most important things. You have understood what we have added and how to add it. It's just today only 4 dependency, but the moment you go for your project and all, maybe you need something extra. So nothing to do and by your own, basically. You go on a Google and just write, sir, Kafka, Spark, Maven. Simple. Kafka, Spark, Maven. That's all. Which Kafka version? 1.6 I want. And that's all. But I will not do now, don't worry. Not today, please. Day 5. But it's not dependent only this much. So whenever you do a project, you know, there are so many things you will be importing. So this is how you are going to do. Those who love Eclipse, process is the same. I repeat, those who loves Eclipse rather than IntelliJ, everything is same to same.
One quick question, Manish.
Please, please.
Like, how will you decide like which version we should take? It's dependent on our Spark version or?
Yes, our Spark version. We just look for the similar or Google it basically.
Okay.
But Maven and all, generally there won't be much this one. Whatever upper versions are there, generally, not all the time, generally, it be compatible with all older versions. So all updated versions are compatible with the older version. So it's recommended that you should not go with the older one and not very beta version also. See here, now the moment I will ask you on the day, so I will go ahead with any 6 versions. Because 6 versions, see, approximately June 26 has been released. I'll not go with the 5 because 2015, oh my God, very old. So I'll go with any 6 latest one. Any latest one I'll go. And if something compatibility issues will come, automatically error it will show. It will show clear error that this is the problem we have. So you can use a dependency add up, and this is how you can create a Maven project. Once Maven is done, you can write anything related to Spark and your IntelliJ will not complain that I don't know Spark. Now what IntelliJ you are looking, that knows what is Spark. This guy knows what is Spark. There is no problem. All right. Now, my dear friends, click on the file src main Java. Please have a look. This kind of a structure already got it created. This kind of a structure already got it created in your system. Please have a look. Is it created? If yes, please confirm. This structure automatically will get created during the project creation's time. Sometime it doesn't get created, then you have to create by your own. But in that condition, multiple error comes in, you know. Now, right click on the Java, click on Java, and then right click, please. right click on the Java, and we are going to create a package. I repeat, right click on Java, new package. Package means you know what is the package. Java already training, you have it. And all package name, you know how to write it. Com dot maybe Spark training dot jpmc. Whatever name you write, it's fine. Com dot Spark training dot jpmc. This is the, or any name you write it. You know, package name always be write with the com dot. So I'm also using the com dot. So you also do the same. You also do the same. Hit enter. Hit enter. The package will get it created in left side. Package will get created in left side. I'm waiting.
Manish, they are asking to repeat once again.
One second. Okay, no problem. Guys, aram se. Sorry, I got little faster. No problem. Java is there. Java. Those who are getting a problem, can you respond to me, please? Are you able to see Java left side? All right. Right click on the Java. Right click on the Java. No, don't end. 1 minute. Right click on the slowly. Java. Right click. New package. I'm waiting. Clicking here and write any name. Maybe I'll say now com.manish.jpmc. Any name you can give, your choice. We have a no problem. Click on. The moment you click, you will be get here left side. Hit enter. After writing, hit enter. It will come up. I'm waiting. Slowly, guys. Yeah. No, today if slow means fine, because tomorrow I don't want to struggle. Actually, last training, I don't know, 1 or 2 people are saying, but not now. Somebody told tomorrow morning, somebody will say tomorrow afternoon, sir, not working. Form is not working. So that creates a problem. You got it left hand side, com.sparktraining.jpmc. Everybody got something here. Here it has came, right? Left hand side, you are able to see the similar kind of a structure. Everybody please confirm. Are you able to get this? Chandani, any problem? Are you able to see this left hand side, Chandani? com.sparktraining.jpmc or something, you got it, right?
I have given the name Manish, but what needs to be done? I should hit a enter to see it left hand side?
Hit enter.
Okay.
Keep on speaking, guys. If you have any problem, keep on speaking. Anybody, feel free in my class, please. Feel free in my class. Morning, I did some promise, right? I have to prove myself. And morning only I told, it's not like I will teach everything, but whatever I'll teach, transparent, clear. Everybody got the similar structure like this. Now, this is the package. You know, package means what? You go to a gym And people say, sir, 12 months ka package is there. 12-month package. What is this package? Or we go to our canteen, they say there is a combo and that costs this much or something like this is nothing but the package. So package means everything inside the package I can use interchangeably. That is called package. So I have created one package, and inside the package, whatever classes I'll make it, I can use them one to the other and other to the other. So for that reason, package we have created. And now inside this package, I am going to create one by one program, or I am going to create a Java class. Class is nothing but the one program or one job, one program that will be having a main method or something like that, and that will be executed. So inside the package, we are going to create a class. So class can be with the main method, then I can run it. Or maybe for class and all together I want to use, that also possible, because everything is available within the same package. Now I am going to right click on my package. Guys, have a look. I have my package, right click, new Java class. Right click on the package name, new Java class. I am clicking. It will ask, sir, give me the name of the class. So I'll say hello world. Hello world. You know camel casing we write. So I am following the same. First letter, capital letters. Not necessary. You can write anything, but you know, a standard way of writing. Hello world. I have written hello world and hit enter. And hit enter. It will open a new page with your program. That's all. That's all. Now in this program, I am going to write print hello world. You guys are the expert of Java. Can you print hello world? Write a program to print hello world. Over to you. Write a program to print hello world. No, I will not help. You need main method or not, I don't help. I want to print hello world as output. Run it and print me, sir, hello world I am getting, that's all. No help at this point, please. This is help I'll not do. Yes, everybody has printed in somehow. It's good. Hello, Pani. Is it working for you? Pani, without that simply system out.println, is it working without main? Hello, Pani. No, then. Firstly, you have to write main method and then only you can write, right? And for your kind information, I have run the same and it is showing me hello world. If output is coming means my POM and everything setup is everything correct, there is no problem. All setup is done, there is no problem. My IntelliJ is ready to get launched. Everything is fine. Everything is fine. Hello world, you have done it and it's working absolutely correct. Everybody, can you confirm? Everybody is able to print hello world? And we are all set to kickstart our Spark things. That's all. So now sometime is there, instead we will just try to do some questions and answers, and then tomorrow we will start with the RDD practicals. RDD practicals, we will start it tomorrow. Is that fine? Because it's late evening. If I start, I need minimum half an hour and all. So why to get into that? Yes, guys. So some time we have. So we'll just talk with the questions, answers. You have some doubts. And then lastly, I will ask a small verbal feedback. It's about you and me. That's all. No about RPS or no JPMC or nothing like that. It's just between a trainer and my participants. That will be a verbal feedback, either in chat window or something, but that is lastly. Now questions, please. Now questions, please.
Hi, Manish. So one question is, how do you visualize the RDDs, basically? I think RDDs looks like the starting point for everything.
Yes.
For the Spark process.
So that's why I have taken that T example, right? RDD are nothing but going to be your variable. This is just a variable. It's just a variables. So just like how you do the visualize variables, it's going to be RDD. It's just a variable, nothing apart from that. Don't think too much complex. That's what I don't tell RDD ka full form, or at least day one. Because by hearing the full form, people get confused. Sir, it's this simple variable. How you do A is equal to 20. So the moment I rate A is equal to 20, it takes go and sits in my RAM right now. But RDD, it say A is equal to load a.csv. It will not take RAM now. It will take after tomorrow or once I'll call an actions. Only that. Apart from that, there is nothing. There is nothing. So in the code directly, you can say, oh, this is my RDD. And anything and everything, all operations on a RDD, it will be RDD. So it is not, yeah.
So can we consider it as like the entire data that we wanted to, data source that we want to process, for example,
yes,
as an RDD source, or
yes,
it should be sharded, or it should be chunked?
No,
to begin with.
chunked. It will be there in a chunked, but entire data is RDD. But we don't say it's RDD is a data. RDD is just a variable. RDD is just a variable which consists of the data. And the action was called, not all the time.
It's an instruction, just an instruction.
Yes,
lazy.
Instructions. Yeah. That's all.
Right. Okay. Yeah, I think probably will understand more about RDDs tomorrow.
Yes. Tomorrow, whole day the practical only. There is tomorrow no theory. I have finished everything. Tomorrow theory, everything I have finished. Tomorrow whole day practical. And not tomorrow, remaining all the days, except day 5, again 2 hours theory.
Okay. So if for example, if we have a database with maybe like a couple of tables of data, for example, and each table data should be considered as one RDD. If we are trying to process together, it's like those are two big tables in Cassandra, for example.
Yes, that will be RDD, one RDD, and that can have any amount of data. True.
So it's like to begin with, a table where we can correlate, we can directly proportional with an RDD, for example, to begin with.
RDD, yes. No, tomorrow we'll be starting with the arrays, and then I'll give you Excel. Any file will be loading, and then we'll be doing manipulations like that. So, Database table also is a file only, right?
Hi, Manish.
Mm-hmm.
Yeah, while I'm running it, it's saying like unable to access the jar file.
Jar file? Something pom.xml, some error is showing?
No, hello world program, right?
So in pom.xml, any error is there?
No error in pom.xml.
Everything is green, it's looking. Nowhere red color, you are not seeing any red pen, right?
Yes, no red in pom.xml.
See here in my code.
Can I share my screen?
Okay. Please.
So, please let me know once if you are able to.
Yeah, it's coming now. Yeah, it's coming. Unable to assist the job.
This is the program that I have written.
1 minute. There is a problem with the program. Open the hello world program. In right side, there is a tab. 1 minute. There is right side. Next tab. There is, you have written something wrong, right? String, something you have written, it's wrong. It's showing red color, right? And hello world at the top in tab, you see red color it is showing or not? So if it is red color means you are not supposed to run the program.
Okay.
Red color is there. No, why to create it? S capital, simple. S capital, if you make it will be S capital. That's all. See, all string class has came. Are you able to see the string class? Yes. The moment everything will be green, then only you can run it.
So, okay, and now if I execute this, then process with finish code 1.
No, now save it first of all. Save the program. 1 minute. Save. Click on the program, save it. And then
here only, right?
Save it. And now run it. Right click. Control S, yes, right click and run it, the program. Run hello world main.do. Yes. 1 minute, it's building. It is taking some time, just a second. That's all done.
Okay, fine. From here we have to run, right? So here.
No, in the program also, 1 minute. In the program, right click and see.
Okay.
There also.
But here, from here I am trying to run this.
Yes, you can run it. No problem. Actually, what happens whenever you make a changes, it's better option to save once and then run it.
Okay. So
sometimes that changes doesn't reflect. Right? Changes doesn't reflect, so it's create a problem.
Okay. So how to save? Like from right click we can save.
Control S is there, and below also save option will be there. Control S to save the file.
Okay, fine. Thanks, Manish.
Yeah. All right. Welcome. All right. Any other questions, my dear friends? Please. Anybody else? Any other questions? If you have, please do ask. Yes, my dear friends. Any other things for today?
Manish, one quick question. So, what are the basic Java topics we require from
Java? No, how much more expert you are Java, that much better you can work with a Spark. See, Spark is just a framework. Spark will not solve your problem. Problem to code you have to write in Java only. So Java is the language. You have to be expert of the Java. If not, then SQL way you have to work. So find SQL we have to work well in that case. But Java too, you have to be very expert. Else you can't work with unstructured data. You have to stick with only with the structured data. Because SQL means only structured data. So if you are willing to work with any variety of a data, you have to be expert of Java.
Okay. Okay, Manish.
Yes.
So
Yes,
as
my
it,
dear.
Manish, as it supports other languages, right?
It supports, but that, again, either you have to learn any one language, either on a structured data, either Java or Scala or Python, or not R. R is not that much, not R. Either
The
of the
people
language.
who know Python already, do we need to learn Java as well for unstructured data?
No, then Python only is better. Then make your life in Python itself. PySpark. We call it as a PySpark.
Okay.
Yes.
For Fridays training, if you are looking for any specific Java topics, it would be very, very helpful if you paste those topics so that we can just refresh ourselves and come back.
No, here everything, classes, all topics, everything means all concepts is needed. But I'll not go in a big deep of the Java. I'll be talking in a Spark way. But ultimately you have to solve the problem. So problem in the sense you should know how to write a functions, how to call a functions, and let us suppose I'll write, okay, solve this problem. So you should be able to solve that, right? So it's not one two topic is there. It's the entire Java you have to be expert. For our training wise, though, it's fine because I'll be teaching with the Spark way only, right? Only the Spark I'll be teaching. And for a Spark, how much Java is needed, I will teach. And I'll show the demo, everything. But in the project, too,
Okay, just I'm asking about our training only.
One more time.
So just I'm asking about training only. So for training to get more clear understanding, what are the Java topics we require?
Normal how to write the functions and all basics. Normal Java, how to write the functions, what is tuple, how to give the arguments, how to call it. So that kind of things is enough.
So in the demo setup, I could see only one program that was there. So I feel like if you can upload all the code to there, right, in the demo setup, so people can execute that code and they can get.
Yes. Yes. So here there is one small disclaimer is there. Your choice. It's a Java, and until you type it, you don't get any expertise. Believe me. Your seniors also or your old batches people, they only recommend no, don't share the code. Just you explain once and we will type it. Because just some time back, don't you think some of my friends just now they have typed this one string and it was a string and there was a huge mess. Just one word. Same thing if you write a Java RDD of the type integer or it is of Java RDD of the string, that makes a two different things. And that differences, to feel the differences, you should type it. To feel the differences, you should type it, the programs.
No, I understand that, Manish. Like why I'm saying is like so. I mean, most of the teams over here. So we are these days day in and day out work on Python and shell scripting, those kind of stuff. Okay, so Java is something that we have learned as part of SRE trainings. I agree with that. So what I mean, in the interest of time, right? So we have to cover so many topics in these 5 days. So in the interest of time, what you can help us is like you can keep the code. So people who want to type the code, they can type the code, and who want to
Yeah, that's true. But if I put the code, believe me, nobody will type. It's a hardcore fact. Okay, don't worry about that thing. You keep your focus on the learning perspective. Remaining, let it be on my head. Let me handle it. Yes. I will share the code, but see what happens now in the team. There are variety of peoples are there. Some of them they are weak, some of them they are average, some of them they are intelligent. So little to balance everything. Though who are intelligent, they will prefer no. I will type and I'll run it them. Though who are little weak, so they will say if you copy paste, it will be better. They prefer this one. And though who are medium class, they will say if I will type or something help, it's better. So what I will do, I will explain the code and I will share in my screen for some time. Maybe for everyone, maybe a 5 minutes I'll give it. If they will run, it's better. Else I'll be keep on sharing the code in chat window. So I'll be sharing. It's not a problem to make a justice with all class of the people, though who are intelligent, though who are medium, though who are weak. So to make a justice for everybody, I will just keep in mind and I'll give a equal means fair business to everyone. So I will share it. Don't worry. Yes.
So if you want to execute this in our local system, so only IntelliJ is required. I mean,
that's all. That's all. You start doing it in your system also. It's fine. It will work. You know how to do it. By tonight, you can set it up.
Yeah. Got it.
All right. Yes, my dear friends. Anybody else have anything?
Yeah,
please?
Manish, are we covering any PySpark related stuff here?
No. Why you need something?
Just I want to, yes, we are not much experts in Java, and most of the people know Python, so we want to see.
Oh my God. Then why? Then you request for PySpark, no? No proper communication it is.
So Manish, the thing is like so we have to work on the DPL project. So it is an upcoming upcoming project. All the production support has to work, and which needs a Java knowledge on that. So that's the reason. That's the reason this this training was set up with Java instead of Python.
Yeah. Then so you guys have to learn it. Then I have to be very strict about it. Then you have to type it because tomorrow your L&D department will raise a hand on me. Manish, what trainees are not able to do. You have to type and learn it, guys. It's about the project. Don't take it lightly. Okay, no? So you have to type it because until you type in Java, multiple options will come. See, tomorrow you'll face that whole day you are struggling with the project. Then tomorrow you'll be, oh my God, what is going on? So guys, you learn it, please. Project is going to be. Yes, that's what. Guys, it's getting delay. One quick round of one small feedback, please. Some of them, they are going logging off. Just another 2 minutes. A small feedback, everybody in chat window. How is it? Good, fast, slow, good, better, best? 4-star, 3-star, 5-star, 1-star, whatever. Please, over to you. Any suggestions for tomorrow? Everybody, please. Morning, I did it. One some promise, right? I hope I am keeping my promise. Morning, I did some promise. I hope I am keeping it. Everybody. Make it fast. All right. So, yes. So with this small, wonderful sessions for the day. Yeah, it will be done. Not a problem. It will be done. Not issues. Yes. We will see. Not a problem. We will speed up based upon the things.
Tomorrow at 10 o'clock, right, Manish? Class?
Yes, 10 o'clock tomorrow will be starting. All right, guys. Let's see you tomorrow morning, 10 a.m. Thank you. Thank you very much. It was great journey to you all. Thank you very much. See you tomorrow. Thank you.
Thanks. Bye, Manish.
Thank you so much. Thank you.